so that everything gets captured. But again, what we were just discussing is when you have the time and the opportunity, make sure you go back over those exercises in the front part of the book, because they'll really reinforce some of the tools that we've been talking about rather quickly. Okay. So as a result of that, if you will go ahead and let's open up that sample from T3 Global again. That should be in your Getting Started folder. And we're just basically opening this up so we can see a reference of what it is we're looking at. And we'll talk about that quick profile tool. I'll show you how the rest of that part works. So go ahead and get that part up and going, and then we're going to freeze off. Go to View, Freeze by Pick, one of the layer that has the break lines on it, so you can get a better sense of what it really looks like. Okay. Now, everybody have that up and going. I don't want to start taking off if you're still waiting for it to load, but give me a thumbs up when you're up and ready. Okay. Jason, Alex, and Jason. Good. Okay. So one of the things to show you here is that it doesn't really matter. Like, if you remember, we built some surfaces yesterday that we looked at, some different scenarios. We've got e.g. bad, 1 through 4, and e.g. good, one, whatever that we had. But what I want to show you is that those surfaces exist outside of this drawing, and it doesn't matter. I can even be, in a drawing over here in a complete different part of the world, and still I can access that surface. Now, the coordinates won't match up necessarily, but when and where they do, or whatever it is, when we show something here in the drawing, if we want to say we want to evaluate that surface, it reads that information from excuse me, from that outside file. It's not really ever drawn in the surface. Okay, so in fact, if you look at, let's look at an extreme case here. Let's go to our surface menu, and let's draw surface and draw the surface boundary. And we'll just do it as a 2D polyline, and we'll put that on whatever layer. And the surface we're going to get is, say, our last good surface that we created. We'll show it. And there it is. That's where we built our last surface. And this is, and it's exactly the same as that inclusion perimeter that we chose. And that is the boundary of that surface. Okay, so that's what it did. It went out, read the boundary of the surface, brought it back in. Now, let's take a look at the quick profile tool, and let's zoom in up at this left-hand corner, upper left corner. And let's go to the profiles menu and say quick profile. Now, there are 3 different methods here, what we call the source of the surface. And if we can choose screen entities, in which case it's going to walk along our alignment that we show it, and where it intersects things on the screen, it will draw it into the profile. Or we could say a 3D polyline, where if we've created a 3D polyline in the drawing, even like one of those break lines or anything else, it will put that feature into the profile and step you through it vertex by vertex. Or we could say surface file, in which case it's going to look at a surface. And we also have down below the place where we can set up to 2 different surface files. Now, be aware, these file names will stay even if you switch to a completely different job somewhere else. And so you may need, always look at that the first time you use this to make sure you're looking at the right surface. You see that one, it says EG bad, and I'm not really going to look at, but this gives you a chance to compare two different surfaces to see, where some differences might lie. It could be your design versus existing. It could be, in this case, we might look at a bad existing and a good existing to compare to see if we've improved things, that sort of stuff. And then once we've done that, in fact, let's take this right now and we're going to go for screen entities. And let's say, okay. And now reading the prompts, it asks us to pick a starting point, or we could type CL and it would ask us to pick a centerline file, or we could type P for polyline and it would prompt us to select a drawn polyline. So you could already have drawn the alignment along which you're going to look, but we're going to just use it to create our profile. Okay, so if we do that, and let's just pick a point, say somewhere in here, and see that little knoll, maybe come across the road over into this area in here, and then pick a point. And now it wants me to pick another point. You can make, multi-leg things, but I'm just going to use those 2 points, and I'm going to say, as the prompt says, enter to end. And so that puts me in this split view. And, when I go up here in the top, I can continue to, press and hold the wheel mouse, zoom in and out with the wheel. I can go down here in the bottom, press and hold the wheel and pan it around, zoom in and out. I have, that's the amount of vertical exaggeration. Fit means it's going to fit everything we're looking at in the window, of course. A 2-time, 5-time, 10-time. Fit is a default. And then you could say draw the plan view polyline, because we click points. If we said that, it would actually go out into the drawing and create a polyline in there for us if we wanted. And you can set some colors. But notice there are things: save, draw, print, help, and exit. Now, we don't have the adjust alignment button in this version because we're intercepting screen entities. Okay, but we do have some other things to pay attention to. If you look at when you move the little blue line, or move the cursor in the bottom part view, and you see how it tracks along what looks like a surface. Well, it's not really a surface. What it's doing is it's intercepting. Go over here to the left, and if I get all the way up to the left, there's as far left as I can get. Notice that is the first thing drawn on my screen that has elevation. The boundary out there has been drawn on, so it's, but it didn't show up because it ignores those zeros. But there's the first thing it gets. So that's where it sets a point and an elevation. And if I come down slightly to the right there, it's where it hits the next one. And you can see in the profile view, a very slight bend in it. That's where it's changing that. So it's going from there to there to there to there. And it gets right here at that green line, at that green contour there. And that's down at the bottom of that profile view. And it's dead flat from there across to there. So you get the idea. Then it comes up, and then it goes from that contour line right there in the plan view all the way up to the next thing it hits with elevation is the contour line over here in plan view. And then again, it goes across another flat spot. You can see that in the profile. But in reality, that's not really a flat spot. That's the crown of the road. So it really right in here where it's flat, it ought to show a little crown, but it can't because all it's looking at are the things that are drawn in the drawing. But this is a good way to sort of evaluate, and we would do it more so with those drawn break lines instead of the contours might be a better source that we would use that to evaluate. Now, looking at the rest of the screen over there on the other side, to the right, it reads out our station, our elevation, shows me the slope of the segment that I'm on. And again, we'll come up here. I'm just going to use the wheel to zoom in and then put back down here and zoom that back out a little bit. But you can see up here on the top where it goes between the two intercepts of the same contour line, it's flat, slope is 0%. Down here, I've got a positive 7.9, there I've got a negative 4.3. And over here, I'm on another flat area between where it hits the same contour in two spots, drops down and gets the next type of thing. And then it's going to, when I get out here to the end, it's going to go across, and that's where it's going to stop right there because that's the last place it intercepts anything in the drawing. Okay, so pretty straightforward in terms of that, and it's a nice little way to sort of evaluate things that are in the drawing with elevation to see if there's a problem with anything. Okay, and one thing to keep in mind, though, that it's really important to keep in mind is to know that this comes in with a vertical exaggeration where it's scaled to fit. And if you want to look at that, and this is what it really looks like. So that, all that elevation change that the contours look like it's really severe, it's not all that much of a change in elevation. It's a little bit. Certainly it's enough to create contour lines, but it's not enough to really think, oh my gosh, if I'm driving on that as a highway, it's going to be terrible. I'm going to fall off the world. So just keep that part in mind, then that you can change that. Okay. So let's hit the exit button and go back. And now let's repeat the command for quick profile. And this time, instead of screen entities, let's choose surface file. And this is the point where we're going to look at one or two different files. Let's just look at the one for right now. So I'm going to choose first, and that's going to be, and you can choose any one of your files, it doesn't matter, but there's my EG good. That's the same one I do the boundary of. I'll say open. And the second, there's that EG bad from before, but since I don't want anything there, I have to hit the second button to let me go and choose a file and then hit cancel. That'll clear it. Okay. So I'll say okay, and I'm going to pick basically the same shape across the same area. Hit enter to finish. And now, I'll zoom this in, zoom this down here, and now look at the difference. When I'm over here on the edge, notice I have profile information over there, even though there's nothing in the drawing. That's because the surface was actually generated out there, and it was generated all the way out to this point right there where you see the crosshairs show up in the profile. That's the boundary of my surface. I come down here and I go across. Oops, sorry. I will do that, and I'll click back down here and oops. Not, zoom this in down here a little bit. So what used to be up here was, there we go. If you need, I'm trying to roll the wheel mouse down here and it kept zooming up here instead of See, it should be zooming whichever window I'm in. There we go. So I switched that to pan instead of zoom for the drag action. So now if we look here, whereas when we looked at it by intercepting screen entities, it went flat. Well, now it's not flat anymore. It has a particular slope. Same thing when we go across this area right in here, right, from there to there, you see it actually has a crown on the road. It's not flat. And then we see when we get over here, we come to that little, see those purple lines. We did not see those when we looked at screen entities. All we saw was going across the contours. But when we're looking at the surface, we see that that has actually picked up it's actually picked up the edges of the curb. So it hits the curb, climbs up to the top of the curb, then comes across a sidewalk, and then starts up this little hillside. Okay. So that's a good way to evaluate what we got. So we come across, this flat part of this hill, we drop down right in here, and we can tell that because, we see that we come into this discontinuity, this wall, it comes into a little retaining wall, drops down, picks up a little more hillside, comes across. Little area here, a little flattened part of the roadway, comes across and goes over the road. And now, even though we're off of the drawn contours, of course, we're going to still be able to see the surface out to the end. Okay. Now, that is that basic type function and how you can sort of, walk your way around. But now watch what these other buttons are going to do for us. This adjust alignment, if I click that, it now shows up in the plan view and it prompts us to pick an alignment point to adjust. Now you don't have to snap to it. It's just whichever part you're closest to. Notice the endpoints, the midpoint, and the endpoint. It would be that way if I had a multi-segment. It would show me endpoints, midpoints, and all the internal vertices. So if you pick nearer to one of the endpoints, it's going to hold. I'm just going to click and let the mouse up. So it's going to hold down the other end of that alignment. So I can now drag it across this way. And you see, as you do, you're actually changing the profile view in real time. So I'm going to drag this all the way across up like this, say. And then you click to put it down. And then when you click back in the profile view, it's back into tracker mode and you can see all the features that it's tracking across. If you say adjust alignment and you grab nearer to the midpoint, then notice it brings the whole slicing element along, keeps it aligned the same way, but it brings the entire thing down at its normal length. So if I put that here, now I have to go back and choose adjust alignment again and get near the endpoint because I wanted to go across the pond a little more horizontally. Then I could adjust the alignment and sort of, move it back and forth, click it down, adjust alignment, get near one of the endpoints, click it down, hit adjust alignment again, click near an endpoint and drag it back so I can shorten it up. So you may have to keep going back and forth to sort of get things set up like you like it. So if I come in here and there I am looking across that perched pond, and I may want a little steeper view of it so I can see it, as I'm coming down. And notice it's not, it's not going from this lower left to the upper right. It's coming from the upper right down to the lower left. The tracker will show you which way you're moving. And if you needed that the other way around, you would just, adjust your alignment, swing this back down in this direction, click it back down, then hit adjust alignment again, pick it up and move it up. And so now you can see it shows us the other direction. Okay, now those are some tools, but here is something that comes up quite a lot, and especially in our work, where somebody may say, you know, your boss might come by and say, well, you know, cut me a section across there. Let me see what that looks like in section. And really, technically, it's a profile. You know, cross sections are a series of slices along an alignment. So this is just, you know, looking at a sectional view, or a profile. And you say, well, I want to see what that looks like. Well, then if you go into quick profile, you set this up like this, whether you're looking at drawn elements or surfaces. And now over here, you've got the option to either save that as a file, or you can draw it by click draw. It's going to switch and load up the draw profile command that you would get in the, just like you're drawing a road profile. All kinds of things you can set up. You've got a horizontal scale, a vertical scale. So let's make that a 20 scale. And we'll just keep it 10 scale vertical. It's just a 2-to-1 exaggeration. You can make it whatever you want. The draw grid, you can set that up to, you know, put grid lines. You got control over the layers, the ticks, however often you want to do it. You can draw it on a paper space layout if you want to, and set that up. You can, you know, all of these things that you can control: layers, colors, text and symbols, line types, labeling, all of these different types of things. And then this link to files is, if you draw these profiles, and if you've saved the profile file, if you then go out into the drawn profile and change it, even if it's just a grip edit on the drawn profile, it can either automatically, or by prompting, or do nothing, tell you that, hey, you're changing the profile. Do you want to update the external file, or are you just changing the drawing? And so it will do all that stuff and can become dynamic. Okay, so let's just take it, assuming the defaults, and I'll say okay. And now it gives us a couple of things: what grid station to start, to finish, elevations, etc. We'll just say okay, take some defaults, and we'll click up here. And there now is that profile drawn at 20 scale. So there's 20, 40, 60, 80, 100. And it goes every 10 feet vertically. And again, you've got control over the text styles and the distance off. And you could even set this to be a dashed line and different layers, etc. Okay, in fact, if we repeat that same thing, and I'll go back and try to get basically the same area. And then I'm going to draw that. Now, I've with the same dialog box up, but I can load some settings here. And I've got in my settings folder, I've got some road profiles, or National CAD standard roads 50 by 10. Let's see what that one looks like. And we'll say okay. We'll say okay. Now you see it's obviously a much larger exaggeration. And it's got things like whether it's going to draw labels. Okay, so you could have some pre-built styles that you want to load up to draw your profiles with. Okay, and so those are things that you would define as you go through things like this draw profile command, where you would load up a saved profile file as part of your road design stuff and could plot those out. Now, that's not it's not something that you in the construction side of things would normally spend a lot of time doing. That's more a design side where you're creating the drawings. You're going to be getting those drawings from somebody else. Really, all you need to do is to read the information on the drawings, like at station, 13 plus 17.83 is the starting station number, and it has this elevation, and then you would put that in and put in the other PIs and put in the vertical curve lengths. You're going to enter that stuff instead of trying to do this from a design perspective. Okay. So either way, you're going to come up with the same type of, of those road files. So once that's done, you can use that tool to generate, whether you draw these, whether you save them, or whether you just look at them. But that's a really, really good tool that a lot of people don't ever use, but it's this quick profile. Okay. So, and that's another thing. If you've got multiple surfaces that you're looking at, we started this with surface down to the bottom, draw surface, and we drew the surface boundary. Okay. Now you've also got things like these 3D views. You've seen this surface file viewer that we've looked at extensively yesterday, but you've also got, and let me see, surface, sorry. You've also got this 3D flyover, and it's basically the same thing, but you'll see it's got some kind of video game stuff in it. So we're going to use a tin file. We'll control our direction by picking the start, and we don't need any of the drawn entities. We'll give it a reference surface. So that's what it's going to read as our base and give us elevations and slopes and all that. And you could also add an aerial image if it was all in the same coordinate space, like state plane or whatever, but we don't have one for that. We'll say, okay. And let's just start here, and we'll go down that road. We'll choose our file, and let's see if I can change that color. Yeah, let's make it a little more neutral. Or you could even assign a texture to that if you'd like, but that'll work. Go to view control, bring up the light levels a little bit and contrast. You can make surfaces transparent. If you're looking at multiple surfaces, now you choose a particular vehicle, or now there's a blazer. You can use an ambulance, a delivery truck, a bulldozer. And then you can choose whether you're looking at the front, from the back, to the left, to the right. And then your view position, that's a pedestrian looking in the same direction as the front, or you could be the driver and then look out the back. So you don't really see it if you're the driver, or you could be a bird, so you're going to be up. You can change your surface shading. It can be colored by elevation. You can see amounts of cut and fill. Now we don't have any because we're only looking at one surface there. So we'll just use, and there's none. You can see the triangles. But we'll just keep it as flat. And I got to go back to that. We could be writing down a design center line. Why it reverted to the red, but anyway. So once this is done, and you can, change your elevations, your distance, your speed, Let's take it up to about 20. You can change the vertical scaling if you wish. But once all that's done, you can just click the run button and it runs. Now use the arrows on your keyboard and you can see it's going to come up here and rock up on the curb and then climb up that hilltop. So you can sort of drive all over your surface and look around at it, and you see those curbs are modeled, pretty nicely. Okay, so if that gives you a better sense of what you're looking at, that's certainly an evaluation tool. Okay. You can start and stop. And if you have chosen an alignment for it to travel, instead of you steering it and start and stop, all you're really doing is controlling the start stop. It follows that alignment that you chose. And, you can just have it sort of run automatically and it loops. You set up your lighting by location and time. Let's see, anything else? You leave a breadcrumb trail. All kinds of lights. You turn your contours on if you want to see those. For instance, change your colors. You can look at this. And as you're running along, you see the window is showing you what those cross slopes, the roll slope, the longitudinal slopes. So now you see how that's reporting that in the window. Use the up and down arrow keys to change your elevations. And then you can, add different models, add different solids. Like if you wanted to, have design buildings and trees and fire hydrants and what have you, there's all kinds of stuff you can really get deeply into this, but it's not necessarily going to help you, do what it is that you're trying to do to try and get this built. But if you're designing something and trying to sell it to the town council, then certainly that's something worth considering doing. But it is a good little tool, and you can, like I said, as you go along, you're going to watch it climb up here, and you're going to see these slope indicators, and they're sitting here in the side. So you could also look at them like this as well. So now you can always read those things with other tools, like run a command, tell me what the surface slope is, click here, click there. But this sort of does it for you in real time, and you can look at it and say, oh, I wonder how steep that is. Well, just looking at that, it's a 53% slope. Well, that was pretty, what is 50% slope? It's, what is that, a 2 to 1. Same thing climbing up here. So you can, always use that to sort of help you evaluate things. Now, this may have been, when you started it up, it might have come in like this. That's just a resizable window. You can make it full size if you'd like. Same as the 3D viewer. Okay. And once we're done, we can exit that. One other last quick little thing about the surface evaluation. You can do these view sheds. Let's see. There's your slope analysis. That's where you can get slopes of points, and it draws them into the drawing. But look at your slope and your surface inspector. Excuse me. Now, this is a little window that's going to, we're going to load up. We can choose, say a different spot if we want. I'll pull this down and choose just points. Now I'll use this plus symbol. In text, I'll just make that 8 instead of 10. Report to station. Nope. Yeah, we can look at it, elevation difference, and let's choose these buttons on the side to load up 2 different models. I'm going to look at our very first bad surface that we had. So that's our EG bad 1. And then look at our last good surface that we made, which was EG good 3. And you can do any number of these surfaces. And you could name them whatever you want to call it. You could just, it doesn't have to be the surface name. I'll just call that one bad, good, and I'm going to say okay. Now, as you are looking at this, notice this surface inspector window pops up. Okay. So now as I hover the mouse, you see where I start to come in, and now my bad surface actually extended out here. Remember, I had those triangles out in here, but there's nothing in the good surface. Now I'm starting to see how much the elevations are, how much cut and fill. So let's look over here. If you remember that retaining wall where I had, those big slopes that came down. And if I click right there, see that puts a label in here that, okay, my bad surface was this elevation, my good surface was that elevation. Same thing, I'm going to come back over here to my edge of my road into this, I'm going to turn my object snapping off so I don't keep grabbing that. So I'm going to look at that. Where's my bad surface is not showing up. There it is. Yeah, right there. And I'll just hit enter to finish. But you remember where we, on the bad surface, we had those stair-steppy looking things. And here's obviously where it really missed. It's 11, almost 12-foot difference. So there was some major difference in our two surface models that we had a problem with. Okay. Same thing over here, we saw, well, there was a 4-foot difference there, or you could just be using one surface. And I'm going to change this text style for a minute. There we go. So, those are some tools that you can use to help you evaluate things. Help you look around if you want to see the amount of cut and fill in a particular area based on the difference in an existing and a design condition. You can use that, but you also have under SiteNet things like the once you computed an existing and a design, then you've got things like this. These reports can give you those cuts and fills. You've got display options where you can display the amount of cut and fill, between the two surfaces, either by contours. You can do labels, and it can put a whole grid series of spots that shows you the amount of cut and fill, and even a color map, etc. So, 12 different ways to do one particular job if you're looking to get those reports and get that information. All right. Questions? Anything that you might think of? Oh, good. All right. So I'm going to close that, and let's go to this Harmer file that we were looking at yesterday. I'm going to just close that down. I'm going to choose Open Files. And I'm going to start in my data folder, and I'm going to look at this examples 4 for that Harmer self-storage. And if you remember, that was the one that had the all of those contours that we were reconstructing. Okay. and elevating with our 3D data menu commands. So as part of that work, and this is actually from an actual file that I did for a client. If we go into there should be in there, there's two extra folders, one called outputs and one called working. If you go into working and choose this hardware storage takeoffs and open that file, it should come up like so. And you may recognize, this is that original that had all those existing contours, and we had that limits of disturbance that we trimmed, and then we elevated things up. But there's all kinds of additional things that are sort of drawn in here. I've got this hatch that's on this thing called TK underscore, that stood for takeoff hatch topsoil replacement. So that's the area of topsoil replacement that was taken from the landscaping plan. And down here's our parking lot, center of buildings, our entrance road that came up in here, and then it comes up to this little area, which is actually an underground detention. Excuse me, where they've, this is where the drainage is going to go. Where they intercept this as to part of this development. Now, the rest of this file, if I look at this, there's a huge amount. I'm going to go up to view, and I'm going to come down here and say thaw/on all layers, and you're going to see all of that mess come in. And this is from a whole lot of different things that were been brought in and out. You can see the red outline is that limits of disturbance. There's this blue outline, which was the original surface boundary that I had created. Instead of using just the limits of disturbance, I actually incorporated the whole thing. But you may also notice that it's a very large file. If I scroll down in here, and I'm just going to do a quick crossing across that contour line, I'm going to look up here, and I see I've actually got 4 polylines in there on various layers. Okay, well, I don't need all of that kind of stuff. I've got these all turned off. So we're going to actually tone this drawing down a little bit so you can work with it a little better. So I'm going to say undo until I get back to that condition. I'm going to go back to my layer control, and I'm going to click the heading up here, freeze/thaw, till I get all my frozen layers on the top. And I'm going to come down here and turn on my existing, my E. Let's see, I'm trying to set it. Our E contour index, E contour intermediate, and then as well as P contour index and intermediate and text. And I'm going to click the little snowflake to turn it back on. So I've got those done and on. The rest of them I'm going to leave frozen. And now when I zoom in here, I can see, well, here's my grading contours. Say this 890. And this one is what, 888. 890. So, let's freeze off. Let's say freeze by pick. I'm going to freeze my topsoil replacement area. Freeze that little purple boundary. That was the daylight line, that surface. And I notice that my contour lines are all sort of the same color, so I might change that with my surface view for my P -CONT. I'm going to type up here to get that down. So my proposed contour indexes, I'm going to make red, and my intermediates, I'm going to make yellow, and we'll give The index one's just a little bit of line weight here, so we can see them stand out a little bit. It may be too much. No, that'll work. So there's now our grading plan. I've got, look at the dashes. They're really huge on that. So if I want to fix that, there's a couple of things I want to look at. First of all, I got this file originally from the engineers, and they had a couple of settings in here that didn't go along with how I like to see my line styles propagate. And there's a couple of settings. There's one called MSLT scale. It stands for model space line type scale. And it really normally should be on. So I hit that command and I turn it on. Nothing happens, nothing changes until you type REA, which is shorthand for regen all, and it will regenerate the lines based on their patterns. Now, those are supposed to be dashed lines, these existing contours. And if I zoom way in, well, I still can't even really see it. Try that one more time. Yeah, it's still, the pattern is not enough. See, if I select those two. Yeah, see, the pattern is still not enough to show up correctly, because if I look at this, I see its line type scale is 1, that's good. This one, line type scale is 1, that's good. But if I look at another variable called line type scale, now this was, remember the last one was MSLT scale. This is just overall LT scale. It's our global line type scale. And if I look at that and it comes in and it is set to 100, well, I want it to be 1. So now that's more like what I would like to see those contour dash patterns look like. Okay. And if it's still just a little large, you can change that, but that's going to affect other line types like the stream, the boundary. So you can do a number of things. I'm going to select one of the index contours. I'm going to then right click and choose select similar. So it's now selected all of those index contours. And I'm going to change its line type scale. Instead of being 0.1, I'm going to say 0.5. So I'm going to tighten it up by half. I'm going to then select one of the intermediates and select similar and set that also to 0.5. Now, you may also sometimes get a situation like this. If you've gotten, let's see, let me set that up to point. So you sometimes will get a situation like this where you'll get what looks to be drawn contours. Select similar. Yeah, they're not. Trying to get one to show as a problem that you get. And the fact is, I don't see any of them doing that now because there's so many contours. Here's an example. It's small, but sometimes you'll see this really bad. If something, like that contour is supposed to be evenly dashed all the way around, but it hits right in here and you see it's solid all the way up to here, and then it's solid around to here. Same thing, this portion right here is real, solid from there to there. It's solid from here around to here, from here over to here. And notice, so that looks like it's longer than this other. Look at this one down here. It's really goes from here to here. Now that is controlled in AutoCAD and in IntelliCAD by this line type. If I look at it, it's set to be, line type is by layer, but that layer is set to be a dashed pattern. Well, the dash pattern normally starts at the start of the contour line, then it runs through the contour line, but every time it hits a vertex, so these little grips, every time it hits a grip, it starts the pattern over again. And if there's not enough distance between those grips for it to get the dash in and the space, it just starts over again, drawing the line. And it didn't get enough room to get the dash in, so it started the line again. Not enough room, started the line again. So it looks like it's a, you know, a broken line. But there is a feature that if you look at the properties of that polyline, see, there's this thing over here in the properties called line type generation. And line type generation for that line is set to no. If we change it to yes, what that means is that the line type definition will now flow through those points without starting over again. So it will generate the line type. So it hits that, and even if that vertex is in the middle of a gap, it will go ahead and still, you know, the grip remains even in those gaps. So it's not really something that you could see. Here's an example right here. I zoom in there. That's the actual endpoint of that segment of that polyline, even though I can't see it here, but that's where it is. So that's what you need to do. If you ever get a situation where you see a bunch of lines like that that look weird, you need to select one, select similar, and then change the line type generation to be yes. Now, that is controlled, or what controls whether that polyline has that property set to yes or no is controlled by whatever the setting is for, let's see, LT. Yeah. PLIN gen. So polyline generation is, oops. P-line gen. So polyline generation is a setting or a system variable, okay, that is either on or off, and that determines whether line types that are used around the vertices of the polyline are continuous or if they dash. It's really, the more formal definition is whether or not it generates the line type. So if it is off, when you create a polyline, then that polyline has that feature off. So if you want most of the time for it to be on, because there are times when you do want it off, like if you're drawing rectangles and you don't want the corners to be in a gap, you can force it to be off. But in the case of things like contour lines, you want them to be an even repeatable pattern. You want those to be with that property on. So the drawing file itself, and these things store in the drawing file. So you would set P-line gen to on, and then everything you draw that is a pattern polyline will have that feature turned on. If you turn P line gen off, then you draw the polyline. It is not set up for line type generation. Now you can change that individually, just like we did in the properties. But if you're tired of doing that over and over again, set this on in your drawing template so that when you start a new drawing using that template, it's already set for you. You don't have to bother to try to remember. Okay, so just a little bit of CAD housekeeping, and it's not totally necessary for anything, but that's the, sort of some of the management stuff that you can do with this. All right, so we now have some visibility that's going to be a little bit easier to work with as to what we did. Now, if you look at this in terms of our existing and our design surfaces, we have this overall existing ground. We've got this design ground. So let's take a look at modeling those and see what some of the differences are based on us modeling things using our civil way, the way we've been doing most of it yesterday, where we collect the elements, versus the site net way, which is sort of the takeoff way, which is based on layer membership. Okay. So we're going to put in a boundary, and let's see if we can find the layer it's on. I'm going to go back to my layer management. Again, sort by whether it's frozen or not. And I want that LOD. There it is, MPDS boundary. Okay, so that would be our boundary that we're going to use. And I see things like that's the edge of my road. That's the edge of pavement. Over here is another edge of pavement. However, those would make really good break lines to control my surface modeling across the pavement. But I see that they're not 3D polylines, they're 2D polylines, and they're at 0 elevation. So if I wanted to or needed to, I would take those edges, set them to elevation based on them crossing those screen elements, which are those contour lines. But that's not going to really be sufficient, because I'm going to go from this elevation as it crosses here down here to where it crosses here. And that's going to be just one continuous change, constant change, where it's really probably not that constant. I also see a question mark here. And if I look at that and I see that is on existing road guardrail. So apparently the line type is not loaded. That is supposed to be for that layer. I'll go over here and look for guardrail. Looks like the road. There's guide rail. Pennsylvania calls it them guide rails and not guardrails. So let's just use, since that guardrail is not defined, let's find one that we do have. Let's load. Something here. There we go. There's our guardrail. And we'll turn its line type generation on. All right, so just a little cosmetics there, nothing big. And again, we could set the elevation to these lines to where they cross. That would be good for brake lines. Is there anything else we might want to do or look at? Let's take a look. I'm going to select everything I'm interested in and view it in my 3D viewer just to see if what I may not be using. All right. Looks like I'm going to be pulling everything on this surface from contours. And that's really all I've got. I don't have any, even if I were to define those road edges, they haven't been surveyed. So really all I'm doing is bringing the, I'm deriving the elevation from these contours, which I would have anyway. Now, I could put in a brake line down the nose of this contour. That's probably not a bad idea. So maybe same thing down this one. Otherwise, it's going to fill those in as flat. So if I look at those features and see where they are, looks like this, the line already drawn for me that goes down the noses of those contours. And it's on a layer called shoulder. And if I, I'm down here, I'm going to just bring this out into the area here a little bit off of that contour so it doesn't intercept it twice. And then maybe I'm going to elevate that one line, 3D data, 2D to 3D by screen entities. And everything is okay for that. I will select shoulder. Might as well get the road edges. Okay, not that that's going to give me a much further definition. There's more shoulder. All right. And then let it read the whole thing. That now has our edges for our roadway. And I'm going to just draw a polygon. I will pick that layer and I'm going to, sorry, just hit something over here. All right, let me turn this off. I'm going to just sort of draw and I type C to close to make sure that it is closed. And I'm going to use that as my surface boundary. All right, so let's go to surface, triangulate and contour. And I'm going to go to my triangulate tab and write the triangulation file. And I'm going to call this, let me see what I have. Let's call it EG from CTRS. I will use an inclusion exclusion to trim the edges, ignore zeros, densify, minimize flats because I am using contours. I'm going to uncheck to draw my contours, make sure nothing is filtered on my selection. That should be good. Oh, now I can't do this quite yet. Because if I go to select everything, I'm going to be getting these proposed contours as well. So I want to make sure I freeze by pick. I'm going to pick one of those index and one of the intermediates. And let's make sure we don't have. Oh, that's as well. So we want to freeze. That. And we'll freeze those labels while we're at it. So that's making sure. All right, that'll be probably good. This may or may not be 3D. I doubt it's 3D. All right. So now we've got other things. Let's see if these stream center lines are, nope, they are 2D. I will join those. I've isolated, I've joined by directly connecting. There we go. I will now restore my layers. I'm going to 2D to 3D by screen entities. I will raise these stream center lines up. Now, the reason I'm going to do that is so that those contour line channels are defined instead of giving me flat spot to cross it. Okay, so there they are. And then finally, we'll go back now to triangulate and contour, make sure our settings are still, they're not. Let's see, EG from contours. Should work. Use inclusion, exclusion is on. Erase previous is off. Ignore zero. Densify, minimize flats. Do not draw the contours. No selection filtering. I'll say okay. Once we select my boundary, which is actually this yellow line, no exclusion. And then what do I want to triangulate? We use everything that it finds. going to give me a couple of crossings. They're 2 feet difference. Everything's 2 feet. Let's zoom. All right, that's supposed to be a depression tick. I think 42. I think 42. But that crosses 840. All right, so it looks like they've mismodeled some of that in that little drainage area. Yeah, no biggie. We'll live with it. There's a couple of feet of difference in there, but we're not going to do any work in there. So we now have built our model for existing. I'm going to look next at, go back and thaw those areas. And we had our proposed buildings. Proposed break lines. And our proposed contours, which were here. And I'm not trying to set it current. Let's see here. Let's don't need that. Don't really need that line. Choose that for visibility. And what else is possibly there? There's our parking. Pavement hatch. Edge of pavement. All right, so that looks like all we need. And now we'll freeze off our existing. Those I don't need to worry about. But all right, so if I look at this in my 3D view, just to make sure everything is elevated correctly, I'll select it and look at my 3D view menu and then spin that around, and I see that I don't have the road edges elevated there. Here I have the actual, there's my finished floor elevations, but the yellow is where the ground goes up against it. So I want to freeze those blue ones, use the yellow ones. I've got some drawn break lines down those corners. Probably should put some more down in here. So I do need to elevate the road edges. And I had them somewhere. Let's see. It's on a layer called asphalt paving standard. So I'm going to undo that, go back to thaw asphalt paving standard. And we'll go back one more time. Whoops. Let's thaw our blue building footprints. We'll now view those one more time. And it looks like now I've got my road edges nice and elevated, my parking lot edges rather. Road edges coming up, my buildings. I'm a little concerned about that right there. I think it's okay. So it's not curbed even, it's just an edge of pavement. Now, by the shape of these contours, you can see that, we should go through and we should have a nice edge coming down those noses to help define that little flat area a little better before you get into the pavement. But we won't take the time. We're not going to spend, 2 hours here as part of this exercise to do that. Let's just talk. We're going to do this to illustrate what we need to do in order to get these two conditions met. So now let's build a design grade, a future ground. So I'm going to go back to surface, triangulate and contour, keep everything the same, choose my select button and change it now to be FG. From contours, the future ground from contours, inclusions, etc., and say, okay, now, if I use this same inclusion area, no exclusion areas, and then A-L, R to remove, I need to take out these two streams. It's going to come up with, I've got a crossing break line, but zero elevation difference, so that's no problem. So now I've got two surfaces made. I haven't looked at them quite yet. So I'm going to take a quick peek. I'll go and get my EG from contours. And I'll see, well, that doesn't look half bad, other than I see some issues down here that probably aren't really that way. Could, well, maybe they are. See, like right in there, that's probably not truly how that goes. And that's probably not shaved off flat. That's probably, got a little high spot or anything, but I'm not going to be too concerned about it. The same little things with these little wrinkles. There's not much we can do about that. So we'll just, yeah, we see we got the stream channel looks pretty good. There was all that 2-foot mismatch down there, but the roadways all came in. Everything looks pretty decent. I'll repeat that command and load up FG from contours and see what that looks like. Now that's our design, and there's you see where if we had put in those edges, through those points, we would not see these little sheer drops, those little stair-steppy things. Okay, so and like in here where we do have them, you see how nicely they're modeled on the edges of our pond. Whereas we really ought to have put them in places like here. Okay. But again, for our purposes, we'll assume that we did, or that there is. Let me see if there happens to be. No, I don't see. I don't see that there is anything there. So, but whoever did the design may have had something there to begin with. But that would be what we do. Now, if we look at that surface again, remember we went out to beyond. So we've got this in these triangles in here don't really exist. Okay, so same thing in here. The only thing we know about this surface is up to the ends of those contours. We don't have this open gap in here. So the rest of that stuff was just, interpolated across those areas. Now I think there is this boundary. It's on a layer called topsoil replacement, which was created by shrink wrap. So now I could go back and model my future grade again and use, oh, nope, doesn't go far enough around. Let's see, I don't think. Oh yeah, it does. There, it's around this. I wanted to make sure it went around the edges there. So this being the, let's see here, draw order front. Now, except it goes down here and it goes inside there, does not come all the way around to the edges here. So that, and that. So I'll replace. Yeah, maybe that's not the. Maybe not the best one to use. Let's freeze that off again. And I'll freeze these two streams. And now I'm going to temporarily isolate those layers. And let's shrink wrap that. If I draw shrink wrap entities, let it go across gaps, we'll give it a medium reduction. Put it on BVY. And we'll see what that looks like. All right, so right in here, we need to bring that down. Oops. All right, so that should define that fairly well. We'll make this one go from oops, from there to there. Then I'm just going to offset that about 5 feet. Get rid of that one. And we'll use that. Now I'll go back to repeat the triangulate and contour, keeping that same file name. Choosing that. Oops. Actually, before I do that, I need to restore. There we go. Now I will repeat my triangulate and contour. Choose my inclusion. No exclusions. Again, just the one that crosses, but no vertical difference. We'll exit that. Take a quick peek. We got the finish grade from contours. And now you see it cuts in a lot more closely around where the surface is. So even though our existing ground goes all the way out to this yellow boundary, and our proposed ground goes up to this white boundary, or I guess we could have used this red line, but I don't have any grading information for this area in here in the middle. We could have done those now. So that again is our process, but let's take a look at a couple of differences here as well, because we've got some surface files that were made as part of this project. So if we look at view, 3D view, surface file viewer, again from the toolbar, it's that one that looks like a little diamond on a computer screen. And let's look in the folder that we're in examples for Harmer self-storage, and in a folder there called working. And we've got this one called EG from C3D, and that's existing grade from Civil 3D. This job was designed in Civil 3D, and I had those original files, and I exported that surface out of that original DG and or DWG file. Okay, so if I take a look at that, and choose open, of course, it's going to be the whole site. Now notice, see, it's got a little bit more refinement, maybe not. See, it still has these chunky looking things on these contour areas. But again, this is what the designers gave me. Now here's a situation right here. That to me is not a very good design. I might myself, I mean, it's not a design, it's not a very good model. I would rather think this goes from here to here so that it goes more along, so that this slope comes down like this instead of coming up and back down. But you know, I'm not going to take the time and effort to try to resolve that. Here's another area where there's flats. So that really probably does something more like that than running across here. So if I put another one up to here, and let's maybe instead of adding these, we'll just swap them. All right. Yeah, again, not really worth our doing a lot of fine tuning like that onto the existing ground, but that's what they gave us in the file. Now, there's another thing to discuss here, and that is when you get a file or a design from somebody else, and who was it? I think it was look back at my notes here. Yeah, Alex Estes, you said that some often when you get the job awarded that you can get access to those files. So even though they can send you a drawing file, if you're building your surfaces from drawn contours or the drawn polylines, you're still getting sort of secondhand derived information. You're not getting the full detail. You're not getting all the triangles unless they're going to give those to you. And they may or may not. And if they do, they may not know, or if they're willing to, they may not know how to go about doing that. Because Civil 3D is a very prominently used software application to do this with. And they may not know how to send you that information. Well, the traditional way or the previous way was to have them create a land XML file, in which case you can do the same thing. You can export a land XML file, but when they send you a land XML file, you can also import a land XML file. It's on the file menu, import. It's also under surface, import, export, and you can import, you know, some of these different formats. So there's some slight differences there, but when you go to file, import land XML, you're not only getting the surface, you're getting everything else that could be in that file, which could be road center lines, profiles, coordinate points, drainage networks, all of that. So that's really the preferred way, and you'll get the entire surface, all of the triangle definitions, everything that is done in that surface. Now, that's one way. The other way is that the guys on the other end of the phone, when you're asking for that, if they did it in Civil 3D, they may say, well, I mean, I don't know, the surface is already in there, it's in the file. Well, that's true if you have a file that came from Civil 3D and they haven't stripped the stuff out of it. Most likely they haven't. It's probably there, but Carlson can read that information directly. Okay, so if I'm not sure if there's any in this one, but I'm going to go to my file import menu and I'm going to choose Civil 3D. And I'm going to say all Civil 3D objects. And I'm going to see, because this file originally came, the DWG originally came from Civil 3D. So I'm going to choose this command and see if it finds anything. And the first thing it's going to ask me, because a land XML file could have, or Civil 3D file could have coordinates in it. I haven't opened the coordinate file yet, so I'm just going to go to new. I'll keep it working here, keep the same name, just say open. Okay, and so it's going to read everything about that file, and it's going to come up here and tell us what it finds. Well, it looks like it did find a bunch of stuff. All right, so at least turned this on Civil 3D-X. All right, so if I look at my layers that start with C3D, boundary, existing surface, looks like all they really had in there was the existing surface. So when I look at that, and so it extracted the surface, trying to see where it's going to tell us what file. Convert Civil 3D drawing. It's not giving me a chance to look at that. It's just going to read what the name is, in which case, let's take a peek. So if we look at our working folder, down below these dot files, they may have been stripped out of these. Let me take a quick peek. I'm going to go to file open. I'm going to go up a level, get the original, that permit set. Now, I import Civil 3D. Looks like it imported labels. There we go. Now it found the surface. It found a surface called existing. Do I want to create a Carlson 10 surface? I'll say sure, go ahead. And we'll put that right where it was. And okay, so apparently the only thing it had in this file was the existing surface. And if I take a view of that one, I can see it's pretty much like the last one that we had looked at. So that was already given to us as part of the DWG file, probably unbeknownst to the originators. But looks like that they've done everything, like right in here, for instance, this probably goes from, say, here to here, instead of spilling out in the road. It's probably a little more like that. Same thing maybe from here across to here, so that it doesn't climb like that. So, you would not necessarily spend this effort, but looks like they did the original modeling. It looks like they didn't bother with using brake lines properly either. And sometimes that's all you got. Can't do anything about it. So you could possibly, resolve a few of them, but I wouldn't waste a whole lot of time trying. Okay. And, if that were in a critical area, you could either try to resolve them yourself if you can figure that out from what you're looking at, or, ask them to go back out and resurvey this stuff. Does this thing go from, let's see. Does it come down here and do that? Instead of doing the way they had it set up a minute ago. All right. And we won't save those changes, but that's one of the things that you would quite often do when you get a file in from somebody else's. Make sure that it, if it came from Civil 3D, go into your imports and see if you can pull some of this stuff out that may already have been created. All right. So there you've got those two surfaces built. Yeah, let me say this. So we built those two surfaces, existing and design. And that's really, if you wanted to figure out how much, as a quick earthwork kind of stuff, you could do something like just run some, volume reports. So if we did a check on that, we're going to, now it's going to ask us for some files. We look up here at the top, it wants to know the existing surface. Well, there's our existing surface from Contours. We'll use the one that we built. And the future ground from Contours as our final surface or final grade. Let me open. So any inclusion, exclusion surface, you could go back and choose the included area, or you might even have a smaller area that you're more interested in. Or it will stop at the boundary of the smaller surface. So, and if you didn't want the buildings included in that, you could set those up, shrink and swell factor. However you wanted, you could report tonnage if you knew the density of the material, etc. You could write a file that is the difference in the two, which is your cut and fill volumes. But anyway, at the end of that day, you've got, oh, that didn't make any sense. Oh, yeah, comparing the same file to itself. All right, so we'll try that one more time. This time the existing file is existing from Contours, and the final file is final from Contours. There we go. And we'll just take that as their conclusion. That's a little better. So that's going to give us 46,000 yards of cut versus 23,000 yards of fill. So they're going to have to haul off about half of their earthwork there. Okay. Now, what this report is going to give you real quickly is real quick preliminary analysis of this. Now, remember, this is not cutting down to subgrade or taking out areas where the pavement is for the parking. This is just simply the differences in the top elevation. But this gives us a good starting point to look at this. And we see, well, we've got a lot more cut than fill. So we're going to have, we have an average over the project of like 6 feet of cut and only 3.8 feet of fill. So here's the couple of key points right here is that if you take this total area, there's my square footage of the total disturbed area, and it converts it into an equivalent cube, an equivalent volume of that, like it were that number squared and then the current depths. So it looks at that averaged cube of material and says, okay, if you just change the elevation, if you raise it up 1.79 feet, on average, you would balance your site. Okay. Now, there may be other reasons why you can't do that. These elevations may be governed by some other kind of constraint. But if you could raise the entire design surface up by 1.8 feet, you could get closer to a balanced condition. Obviously, you can't just pick the whole thing up and raise it up almost 2 feet. You'd need a ladder to get off the road to get onto your road. So that kind of stuff you can't, you have to work out the nuances, but that gives you an idea of something to strive for as a target. And it also gives you this, and this number is pretty important. I'll give you an example of how that came into play on a project that I was involved in up in upstate New York. We were working on something for Lockheed Martin, where they were designing a new helicopter hangar facility. It had 8 bays in it that they could work on 8 helicopters simultaneously, but it was where that they worked on Marine One, the president's helicopter, where they would put in all the avionics and all that kind of stuff. Well, that's all well and good, and that wasn't what we were involved in, other than the architects worked on designing the structure. But it was up to us to design, how do you put the building there? Well, okay, we had the building footprint. We sited it on the property, and it had all kinds of constraints involved. And we had it pretty well balanced, part of which we had to avoid some wetlands and the usual work. So we had it pretty well balanced, and we're sitting around the project trailer one day, and we're talking about this. The contractor is there. And so he knew these numbers. He had these numbers in his hip pocket when he's at this meeting. And the architect for Lockheed Martin, being the ego-driven type of personality that a lot of architects happen to be, and he's thinking, well, you know what, gee, I'd really like to be able to see the building a little more prominently as you're driving up the hill approaching the site. Is what would happen? Can we raise that site up like 2.5 feet? And the contractor, he sort of thinks a minute. He goes, "Sure, yeah, we can do that, no problem." He said, "Well, what would be that difference? It would be another, $4 million, whatever number it was. It was a high number." And the architect goes, oh, that's ridiculous. How can just raising the building 2 feet cost us that much money? Well, he knew this number based on that design and what it's had to be, that if he's going to raise whatever number this is, it computes to be this based on the area of the site and how much he wants to raise it. He had this number knowing how many cubic yards of material it changes when it goes up or down by 1/10. Well, 2.5 feet, that's 25. And so apparently, whatever this number was, it cost him, I don't know, whatever that proportion is, that he knew if it was multiplied by 25, it would reach $4 million. So good number to have. And again, it was that this equivalent report, just real quick and dirty on the cut and fill, that gives you an example there as to what to put into your bids, how much material you're going to have to handle, that sort of stuff. Okay, so any questions on that as a process at all? So we're about a half hour late for our morning break, so we're going to take a good full 15-minute break, and then we'll come back and we'll look at some further examples of some of this work that we do, and then we're going to then we'll have our lunch break, and then we're going to really get into some pretty detailed road design, and then some of the nuances of like the grading, fine tunings, if you will. Okay. So any questions, or everything good for that? So I will pause our recording. I apologize, folks. I've been sitting here talking to myself, apparently, with my microphone muted. I apologize there. Anyway, what I was starting to say is we're going to take a look next at some of the nuances that we can do with their grading tools to pick up and to accommodate or account for things like, the subgrade, additional excavations, and such like that. So as a, I guess as a sort of a a poll of what you might be doing with your stuff at this point. Do all three of you, are your companies using machine control now out on jobs? You know, you get surfaces, you load them in, and you go out and use them on your equipment now?
Yes.
Okay.
We will be.
Okay.
Yeah,
We don't use them, but we provide models.
All right. So somebody else may do your models for you and that kind of stuff. So what is your typical approach to account for the subgrades? Do you typically do a dial down on your blades? Or do you get those as separate surfaces?
you can either load in a subgrade surface and a finished grade, or put in your finished grade and do a hold down.
Okay, yeah. That has been a common approach, is to basically you dial down the distance of that subgrade. But see, some of these tools are going to be able to generate those additional the subgrade surfaces. And so what I want to show you here are just some examples of some of those files that you might use, you know, from the takeoff approach. Now I'm going to call these two approaches we've been talking about, the civil approach and the takeoff approach. The civil approach being what we've been doing. We select the things to model with versus the takeoff approach is we basically give it layer membership, and we do a lot of closed polylines that outline certain features. All right, so or you know, whether it's a pavement in a parking lot, or if it's the slab under a building, that kind of thing. So if we look at some of our projects that we've got in our examples, let me take a peek here. And you have these files as well. Let's see if they're not under there, but. So here's Family Dollar. Now we're going to take a look at let's see, a couple of reports that we've generated out of some of this. Let's see what we got. All right, so here's an example of a project that came in. So you can see it had, you know, existing grades, had the design grades, not only the, you know, not only the contour information, but we also have, like, along the parking lot, you know, we've got top of curb elevations. We've got, you know, typical sections for what the curb looks like. So we know that's a 6-inch square curb with a gutter. So once you've modeled those elements, then how you can set those up is going to be like this. Let me move this over to here again. So that's that same area that came from another one of the drawings in that set, where we see where we have, you know, asphalt paving, and then we have areas of concrete paving, and then areas within the garage. So that's a building that had a slab. These others are just different materials, and it's just for the paving, for instance. And then we had some reports that we got out of the end results. Let me show you that. Sorry, it keeps popping up on the other screen here. But so here was that original design that we saw. And these are just a series of pictures. This is the existing ground now. You see they actually had a graded path in that you can see here from these contours, these dash contours here in this area. And then they resolved that, so this part stayed, but they opened it out further, and this being the existing grade, and then this being that final grade, just the top surface. And then here it is merged, that final grade merged into the existing grade, and then some volumes. That was exactly like what we saw before, the cut and fill. They could have raised 2.6 feet to get balance, but for whatever reason decided not to do that part. And then the volumes with topsoil removal and replacement, and then the amount of cut by depth, 0 to 10 feet, 10 to 20 feet, 20 to 30 feet, same thing for fill. And then that's about it for that report. And then this one is just a volume report, again by zones. That was that same report, but without the cut and fill. And then finally without the topsoil removal and replacement is what I meant to say. So there's that amount as they compare, and then by depth. Now, what that let's see, what does that go into if we did some of these other reports? Let me and that's just a drawing set. Now, this one is the one we've been working with, and we can see a number of different results here. If you recall, that was their existing grade, and then we had that 3 buildings and the parking lot that came up to this upper parking lot as well, or the entrance coming up to this upper parking lot. And you can see those are the building slabs, but the ground around it had had to come down on the sides of the building. So it will accommodate those, and you can see now again it's all pixelated because it was just captured from that screen, but you see it actually incorporates the curbing on that. And get this up here so I can get back to it a little easier. Now this is just the top grades. And there's the additional cut down, say, look, if you notice in the roads there, you can see the additional cut down for the subgrade. It doesn't, you can see it in there as well. And let's see, what we have here. It's the volume report. Existing ground. Final. The final showing the contours. All right, so this was a this was a delivery package where we ran raw volumes, original existing surface to the top of the final grade, and subgrades, no stripping. Again, just the volumes here, total export, the total change to reach balance. Now, when we did this, all these totals, this is where we went through and we outlined those areas that were concrete paved. And here's your asphalt course. So you had a binder course and a wearing course. Your two-way stone, and then we had the stone under the slab. And then we had, out of those things, we had our concrete, our slab stone, the asphalt wearing course, the base course, and the sub base for this, for the roadways, the depths, and then how much paving and square yards. And again, some of the volume reports, and there's the existing ground and the area of topsoil replacement. And again, that just came out of the design drawings. There's our top surface with no subgrades. Final surface, after we've accounted for the topsoil stripping and the subgrades had been dug out. So that's that separate surface. Otherwise, you would have to, in these areas, you would have to put your dial down of however deep that needs to go, whereas out here on these other surfaces, that's not included. You have to keep that out. And there's the final merged into the existing, and then with subgrades as well. Materials costs are supposed to be quantities anyway. Oh, no costs, it says that. Raw volumes. Topsoil replacement we already saw. So that's good for those. And next we had projects here. Let me bring that over. Top of the ground, and this is a building. This is the existing ground, a site, and I'll show you the original drawings here in a minute. They had a building, some parking area, and they drove around, or they tore down that existing building. And then there was a this upper parking lot, so they resolved all of that with this one. I'm gonna give it back over here, and you can see the existing, or they tore all that stuff down, then they put a building back, and it had an upper level back here, and they put a ring road around it, loading dock, complete with stairs in the back. And you can see these areas over here where they had some landscape boxes that they dug in, and you can see the additional depth below the contours over here. That's down to the subgrade. Same thing for the boxes over here, little loading dock on that end. Retaining walls over here on the side. Here it is from the street view. And there you can see this retaining wall right down here on the edge. The final excavation down to, again, the subgrades are accounted for in this, down to the sidewalk as well, the two different building slabs. There's from the back and from the street. There's the top, so that's it without the subgrades. That's it with the subgrades. In from the street, and then without the subgrades from the back. And here is the top of the final grade from the street, so that the subgrades have been built in. So that's the top of our pavement there. And with the subgrades out, and that, and then finally, again, the materials, quantities. At some point, I think we may have assigned costs to them. I was looking for that here. I don't see them offhand, but. And then again, the topsoil stripping zones. Just a raw volume report, topsoil replacements. So that's the replacement after the stripping. So all of that has been from the top, the final base of the final grade, which is the top, then this amount of whatever depths of topsoil has been accounted for as a separate item. And likewise, the stripping. So this part got stripped. And there's the replacement. That's the original. All of that topsoil was stripped away and then replaced with this one. And then I don't know if there's anything in there, really, not so much. Okay, so with those, and here's the actual project files. Let's see, we have $1 million. So this report, again, our volume report, and basically the grading plan. And that's a retaining wall that comes all the way around the site, here with the buildings being cut in. And then that project was an existing building in here, so they got rid of that and then put the retaining wall back here and cut this wall down. That's how that part got done. There's a finished grade with the wall in there. And now there's the finished grade merged into the existing grade around it. I'll show you how that part gets created. And that's seems like that, but there's one here that had a better report that I wanted to show you. Not that one. And here's an example. The lighter blue was merged into the green existing, and there was a retaining wall built down here. And again, some other controls would have been better defined. These edges as brake lines. You see, we've got these ridges going across the road. So although this wasn't necessarily created correctly because of that, on the average, like I said, because you've got some areas that are high, some low, high, low, high, low, on the average, they'll tend to balance out. But you know, would have built the stairs coming up, these ramps. Again, it's sort of pixelated now because these are just reports. So we'll get a couple things there. Some split level buildings with basements. You'll see the stairs coming down. And then they come in and walk out to the bottom. So they're really pretty high intensity grading effort. The job again, identifying the different areas of fill and materials. Existing ground. The final ground, all the buildings cut in. Reports, here it is. The environment reports, area topsoil stripping, replacement, original ground, composite with the final grades. What else we had? There's one here that had an existing ditch going through the site. And then they put this building. And then you see the subgrades have been dialed down for this as well. So the original topsoil stripping, replacements, paved areas. So what we'll look at here after lunch, let's so to put some of those, you get the idea of some of the different things that you would create. To help you. I'm trying to see, where was that? Can't really see that. So just 1 second. This is the one with those 3 storage buildings on it, original ground. We've seen all of that. And those subgrades, with subgrades, yeah, we've seen those before. All right, so what tools did we use to generate things like that? And we'll go to a smaller site that doesn't have a lot of garbage in it, that we can sort of illustrate what those things are going to look like and how you would do those particular designs. So if we go back to, I'm going to load up this Harmer storage takeoff. This is in our example 4 folder. So Harmer storage takeoffs. Let's see if this is the, yeah, so just to have a sense of where we are in the world, we'll just load that up. We're not going to really use this a whole lot for anything. But what we will do with this is, let's take a look at, since we're in this folder, we're going to go to our view, 3D view surface file viewer, and look at what we have in here. And we've got, remember the original grade that we had, and then we had the final grade, but down here are the ones that were used for the takeoff reports. And here's our merged subgrades and our merged tops, and you can see this merged result, and that was the, let me turn off the contours. So you can see that original ground, and it's had the proposed grade merged into that original ground. And so how do we go about doing that? We'll take a look at that here in a minute. If we look at that was the top, here it is with subgrades applied. Again, could have used a little bit more refinement around the edges, but to get these were done for estimating, so they could get a sense of how much it would take to do the effort. So we've got a number of those things that we merged. So we're going to take a look using our, let's see, here's our, with their zones applied. Top doesn't really illustrate much there, but so we had a number of surfaces in there, but we're going to take a look at 2 of these. We're going to use our EG from contours, or no, let's use the EG from Civil 3D, which was this surface. It's our existing ground. And then we're going to also look at and use this FG future grade. We're not going to use the one from contours. Let's use this one called armor storage takeoff BS, that's the base grade. So that's the actual, it says base, but it's not the sub base, it's the actual top of the surface. That's the top of our design surface for those buildings and the roadway coming in and wrapping around. No, that's not necessarily a good one. Let's look at geographic contours. Yeah, that's not a whole lot better. All right, so we've got two surfaces. We have one, and we'll just draw the outlines here. I'm going to go to my surface menu, draw surface, and draw the surface boundary. And we're going to use the existing EG from Civil 3D. All right, so that's that existing surface. And now we'll draw the other one that we're going to use, draw the surface boundary, and we will use our FG from contours. Let's see, let's use, well, either one of those doesn't matter. FG from contours or takeoffs dash FN, that's our final adjustment. So there's the actual outline of that surface. And we can just freeze off the topsoil replacement. So now, so this is the actual, excuse me, extent of the final grading. And it's going to need to go into our existing ground. So if I view 3D view, go to my surface viewer, and I'm going to look at my EG from Civil 3D. There is that particular surface. And I'm going to go to my models tab on the right, and I'm going to choose the surface category, right click, and I'm going to add a surface. And I'm going to add that dash FN. And it's going to come in. Now notice what it's doing. You see it sticks out a little bit on the fill areas. And you can see, you know, underneath where it actually, you know, pokes down through that existing ground. Now, what can we do with this is you can go to these two surfaces and here's our existing ground. If you right click that and choose edit your surface properties, and you can set the transparency of a surface. So now you can see with the existing ground sort of transparent, you can see through it and see where the finished ground lies underneath it. Okay, so, but what do we do to get those two combined into a single surface if you needed to do that? And the way you do that is you go to our surface menu, and there's this triangulation file utilities. So when that runs, it's going to bring up another window, and you're going to, first thing to do is to load a TIN file. So we're going to load that existing from Civil 3D. And it's going to pop in here, and you'll see it, and it's got some of the same controls, and you can color in the triangles or not. And so once that's in, and there's a couple of other things that you can do, but we're going to hit the next button, and we're going to get, color this back in again. Oh, sorry, let me spin it up like that. So now you have all these different things that you can do. Now, here's an example of a quick way to get your subgrades. Let's say you knew that you had your final grade was at the top, but everywhere you were 8 inches below that. And it's not often the case, but if you had a situation like that, you could simply come in here and down here where it says these different controls, you can subtract a certain distance. You can subtract a value, or you could subtract another surface file. Well, you would choose value and then put in like 8 inches, and then it would drop that particular surface in elevation. So remember back when we had the reports that said amount to raise or lower the surface to achieve balance, and it said like 1.79 feet. Well, you could have that finished grade and you could load it in here and then simply subtract 1.79 feet and then come down here on the output and save it out as a separate surface file. And that had been lowered at 1.79 feet. Well, then you got to tie in the edges, of course. So you can't really just do that wholesale, but that's some of the controls that you have. And you can see all of these different things that you have. You do colors. You can, when it says actual colors, it's going to read the 10 file and actually apply the colors of the triangles that have been assigned, in case you've done it where like subgrades are all different colors, like you saw the gray pavement and the blue buildings and that sort of stuff. Well, what we're going to do, and this is by far the most common thing that we're going to do this command for, is to merge a 10 file. So we're going to combine two surfaces. So if I merge a 10 file, and it says, all right, we have to choose a particular merge type, and it comes up in default as the one that's most typically used, where your second 10 is inside and the current 10 is the outside. And it's going to transition the two edges, even if they don't match. If they're not matched right along a daylight line, it will take care of filling that in for you. Okay, so then you can also do the same thing here, but adjust the elevation of the second 10, that type of thing. If you adjust the elevation, you can remove the current 10 where it overlaps the second 10, combine and repair the gap. And that would just be where, like you saw that original grade sticking out from underneath it. So we're going to want to do this second 10 that we're going to be asked for in a minute inside our current 10, which is the outside boundary of that transition. Okay. So at this point, then you could also assign the colors for included and excluded triangles. So you would see the second 10 will show up as red and the outside would be green. We'll go ahead and leave those on so you can see them. And we'll say, okay. And now ask us for that surface. And I'm going to use this -FN surface. You can use any file, it doesn't matter, as long as they're in the same footprint. So now that's where that is. And you can see what it did was stitch the edges together there. And here's where, see, there was a vertical difference between those two, and it just chopped it straight down like a cookie cutter. Okay, so that may or may not be what we really wanted to do with that. And if that's not the case, we can back it up a step and come back to this and try it again with merge 10. Let's see, let's do as the boundary is used to add the intersection point from both 10s, the elevation of the second 10 is held at the boundary, adjusting nearby triangles of the outer 10. We don't want to do, we want to, let's look at, that's cookie cutter style here. Ignoring break lines, and that's combine the history. We still really want that one. I wish it didn't do that. Let's try this one a second. Let's see what that did. Yeah, that blended the edges. And it's still got a bit of issue. Let me see about. Ah. I think I know what it's doing here. That FN is actually included, so I've got all this doubled up. So let's not use that as our second. Let's go to merge 10. And instead of using that, let's use our FG from contours. See if that'll give us that differential. And it's still got those high spots like right in there. Try this as an option, back to that. Final. I think that pulls that blend back. A little bit more like what we really are using. All right, so that's going to give us that merged surface, and we come down here on the output and we do a save as, and we'll call this one merged dash class, just to give it a new name. Save that. We'll come down here, we exit our viewer. Now we can view that as a surface by itself. There's our merged class. We open that up and it's now there. I'll go back to my model tab and it kept that opacity dialed down. We're going to bring it back up a little bit. So now we have this, even though you see the two different colors, because we told it to go ahead and show, which are included and which were excluded. But it's still just a single contiguous surface, which you can see some edge issues. But when you tie those things in, as you're going to see with the road design we get to after lunch, they're going to blend a lot nicer on these edges out here. Because it's generated and it uses that ground out there as a target instead of just ending where those contours end. Okay, so anyway, that's where you would do that and output those as a final surface. So if you needed to do any kind of adjustment work out in there, you're not off the edge of that surface. You've got that information out there. And again, all of these surface files are then available to output, as to whatever your equipment needs. You either do them as a direct Trimble or TopCon, or you can generate those as land XML files and bring them in. And I don't know, is anybody using Carlson grade on your equipment? Or do you all use TopCon or Trimble or Leica or what?
Top on.
We'll be using TopCon.
Okay. And that's by far the most popular one out there in the world. So that part is handled for you. You would just simply export that out as a Topcon TM3, and then that's the file you would put on your controllers. Okay, so, and again, the ones that you output, say once you do that, now I don't have anything to show you that file, other than it's just going to create the file. But the ones that you would output is if you wanted this FN, that's your final, that's the grade after it has had the subzones, the subgrades subtracted, and the topsoil stripping replacement accounted for. The BS, that's your base final grade, which is the top of the final grade without any of those zones in there. There is this one, which is the zones, but not the topsoil. So, and again, those suffixes come from your settings, Carlson configure takeoff site net settings right in here. Okay, so that's your before your design surface before any adjustment. This is after your subgrades, and then this is after the topsoil strips. That's your final topsoil replacements. So then we're going to, well, we're actually into our lunch hour here a little bit. So we're going to come back and sort of shift gears a little bit and pick up a road design so we can see how that gets done. And that's more readily done in civil. And even if you're in the construction module, I switched my menus now for that. It has a full roads section, and it has, the center lines, the profiles, and there's that quick profile, cross sections, your design template, and it's got these two down here, the road design processing and the road network. That's the two biggies. Now, this is all handled under one menu here. Whereas if you are in civil, you have far more on roads. You've got a full set of centerline tools, a full menu full of profile tools, a full menu full of cross sections, and all of these other things for template design, processing, network, work, using cross sections as part of your designs, etc. So there's a bit more in civil than you get in that other module, but you can do those in that other module as well, if that's what you happen to have. Okay. So any questions on that part? Yeah, we're gonna, when we come back after lunch, we're going to, like I said, shift gears over into the roadway design. And then we're going to wrap up with a little bit of the stuff that we can accommodate these subgrade zones under different things like slabs and parking lots, that sort of thing. Everybody good with all that?
Sounds good.
Okay, well, like I said, I'm gonna give you your full hour. I'll give you not just your full hour, but a 3-minute bonus. So let's come back at 1:10. And so I will. Okay, so
Hey, your volume's not working.
Yeah, I was about to say.
Wow, I'm really sorry. I thought I'd unmuted that, but apparently it did not unmute, or I accidentally tapped it twice. My apologies. So you should be able to hear me now. Okay, looks like it's on. All right, so. All right, thanks there, guys. All right, so what we're going to do is sort of step into the road design a little bit here. We won't have enough time to do a full, like a civil class treatment of road design, which is where we do some of the the deeper design with some complex template designs and tie-ins and such, but you'll see how the tools will work. Now, what we're going to focus on here is a longitudinal design of our, excuse me, of our road beds, which includes the cross-sectional shape and fill materials that we use to build the roadway and then tie into our existing ground. And then, you know, what you can consider or appreciate is that when we have a file like, say, like this, you know, we could go in there and put in these edges and then tie them into the ground, and we compute the material volumes by comparing existing ground to proposed ground. But and that's a vertical volumetric approach. What we're going to be doing with these tools is going to be a horizontal approach, where we're going to slice the road at certain intervals, calculate the areas of those materials along that slice, go to the next interval down the road, slice it, calculate those areas, and then find an average area of the materials that are either cut or filled to make the roadway in that segment. That's called the average end area design. So our 3D design on that part is going to be more horizontal based than it is vertically based, although you're still going to wind up with a finished roadbed surface, finished road corridor surface. All right, so excuse me. So we're going to get this to there we go, the right size. I need to move the pages. Okay, so and that's where we're talking about here. We're going to talk about Carlson's 3D design approach. It's going to be horizontal alignment based. So that's going to push that down the alignment, and it's going to raise it up and down by the profile. And then their cross-sectional shape will accumulate those materials. So we're going to need a center line, we need a profile, and we'll need a template, and then we're going to use it as a surface design that has our existing ground in it, so we can tie into the excuse me, I'm so sorry, losing my voice here. So let's go to our getting started folder, and we're going to open up this roadway design base as our starting point. So I'm going to go to my Carlson. And I'm going to Open files. I'll be in my getting started folder here. I'm going to find that file called roadway design base and choose open. Now, this is a file that we received as a Civil 3D file. And if we look at what's actually drawn in the drawing, all we can really see there is that alignment. If I select one of these drawn contour lines, notice that the entire thing shows up. Now, this is a clue for you if you ever get a drawing like this and you select it and the whole thing shows up and you can't really see it in 3D. If I look over here, I see it's an AECCDB surface 10. So it recognizes that it is an object, but it doesn't know how to deal with it because that is a Civil 3D object. Now you can do certain things like set some behavior here, what layer it's on. Let's see if we've got any. You can set its visibility to no if you want, and it just goes away. Okay, so we got to get that into an object that we can use with our work. Okay, so coming from Civil 3D, we can do a couple of things. We can select it, and then we could explode it, and that would turn it into a block. And then we could explode that block again. And then that would turn all of these little polylines into little bitty line segments, and then we'd have to stitch them all back together. So like we did before, we're going to take a look at our import information under Civil 3D, and let's import Civil 3D objects. It wants to know a coordinate file. Again, I'll just choose new and let it go to the default. So it's looking for coordinates, it doesn't find any, and it's looking for all these different things. And finally, it's going to come across the surface and said, hey, I found a surface called phase 6 original ground. Do you want to create a Carlson 10 surface? Well, let's say yes. And we'll just keep that same name. Choose save. There's one already in there. Yes, go ahead and replace it. And notice that when that happened, you temporarily saw that thing blank out and then come back by itself. So now if I look at it, I have the contour lines are now polylines, and they're on layers C topo major and C topo minor, because that's what layers those were displayed on as part of that object in Civil 3D. And if you were so inclined, you could do things like remove those little tie over sections. They're not really valid contour lines, but we're not going to bother, other than maybe a couple that we see. We've got an issue down here with some things. And again, all I'm doing is just modifying the actual polylines. I'm not doing anything at all to the surface. If I wanted to make those changes to the surface, and I've got a little spot down here that might be a problem. So if I wanted to modify those as making them part of the surface, I would have to then go back and rebuild the surface using those contours. Well, there's no need to. I've got a surface already built. I'm going to take a look at it though to verify it. So I'm going to view 3D view surface file. And I'm going to find that file right there, phase 6 original ground. I'll open it and I say, okay, well, that looks like original brown. Now right there's where you see that little possibly problem area there. We've got a possible problem there. We got, you know, a not very well created surface, but sometimes that's all you can get. And that's all we'll work with. You see the tops of these are now sort of truncated off. Because when they built this surface, all they used were the contours, and that represents a level surface across there. So anyway, we'll live with that. Now, let's also take a look at our 3D view drawing viewer and see what else we might have in their drawing. And we spin this up and we say, oh, there's a bunch of things down here, these skirts that are sitting underneath it all. So if we look at that, and I'm going to spin up my model here a little bit, you can see them now. That's again left over, and it's a whole bunch of these little 3D faces. And I don't really need those, so I'm just going to get rid of them. So if I select one and then right click and choose select similar, you see I've got them all selected, and I'm just going to delete them. And now I'm left with, here's a 3D polyline that goes around. I can use that for my boundary. Now, because I spun up my view, I'm no longer in plan view. I need to go back to plan view. So I'll type plan, hit enter, and enter again for the current UCS. So now I'm in plan view. So if I needed to use this boundary for anything, I've got it there. I don't really need to. I've got the surface, and I can see if I draw my surface boundary from our extracted surface, it's going to draw and it put it right down on top of where that other one was. And it's a 2D. Okay, so I don't really need it. I can get rid of it. If I didn't want that 3D, I can make it 2D. And again, you don't have to do this, but you can, on the edit menu, turn a 3D entity into 2D. Down here at the bottom, enter. By default, it's 0 elevation. And select our entity and hit enter. And that's now a 2D polyline. And you could even do something like reduce the polyline vertices. So now it took 833 vertices or vertex points out of that. So now you can see it's a much simpler line, and it's geometrically in the exact same place, but down at 0 elevation now. Okay, so what we have here now is a starting point to use as a roadway alignment and our ending point for a roadway alignment. And we're going to use this and see some of the centerline tools and what we use to do with it. So we go to our centerline menu. Go ahead.
Hey, Ken, my computer glitched up and froze when we were trying to get when we were in 3D view and we were getting rid of the.
Okay. Is it still locked up?
No, I'm freed up now.
Okay. Go ahead and lock that back in, or load that file back in. It's called roadway design base. Anybody else have issues with theirs? Okay.
And I can't load any of your 10 files, so I'm just kind of writing everything down and just going through it.
You can't. Okay, let me see. Who
I can't pull them out of data folders or nothing. I mean, I've got what we're looking at pulled up, but mine don't have no elevations, and I can't get my 10 files to come in because it won't load them out of that data file. Well, that data folder we downloaded.
Okay, let me take a look at something. I'm gonna have you go down to the share screen button and share your screen. Click that button and then choose the screen you want to share and then hit the share button. Okay. Now, I'm going to request remote control and go ahead and grant that for me. Okay. Now I'm back to this, and if I select that, see, that's still that AEC surface. All right, so if I import Civil 3D, I'm getting started. That's good. I'll open that. Yes, I'll save that surface. I'll make sure I'm in the right folder. Ah, I see why. You see right there, it says temp4 datasets.zip. You're actually in the zip file. Somehow or another, you've made a zip file out of this. So let me cancel that. Let me go ahead and exit this and fix your surface, your file here. So we are in data sets, getting started. I don't see. Don't see any zip files. If I look at, let's see, drive C, Carlson projects. Oh, Carlson 3D class. Let's see, where am I? Where is this folder? Your desktop. Okay, so if I'm on my desktop and look at my Carlson 3D class, you're taking these out of the zip file itself. That came down to you as a zipped file. So what I'm going to do with that then is I'm going to extract all of these and put them in, let's see, if I extract all of those, there we go. So now let's go to our desktop, Carlson data sets. Now the files have been extracted. I can get rid of this. And then now So this comes up. And I'll select that. I see that's still our data set object. And I'll bring that across in now. Getting started. I'm going to say yes to all. And I'm going to put it now, instead of buried in the zip file, which we no longer have, I'm going to put it in getting started. So now it's there. We have these as individual polylines. And if I select one of these, select similar, delete them. Oops. Turn to a 3D object, to a 2D at 0. Reduce polyline vertices. Go back to plan view. There's now my minimal boundary. Let's see, what else do we need to do? We'll go ahead and save this. But now let's look at,
Mine's not letting me select the, I guess the offset lines that we're looking at when it's down in 3D view.
those skirts.
Yes,
Okay, did you zoom up your CAD view into 3D? Or
yes, sir.
here's another way you can do that. You go to your 3D view, drawing viewer, and just grab some things to view. And then if you spin it up so that you can see them in the 3D viewer, then go to the settings tab. And over here in the middle, there's these buttons to set the CAD view to that current view. Tells you it's now set, then you exit. Now you should be able to see them.
Okay.
Got it? Okay, so now you should be able to view with your surface file viewer. These are all the different surface files that are contained in that folder. We're in getting started. So we've got one that's a basic road merge, design pad, some different things that were pre-done for you. But here's the one that we extracted right here, this phase 6 original ground. So if we open that up, there we can see that original ground, and you can maximize that if you'd like. All right, so that is, what that original, what that design base is going to look like. All right. So now that we no longer are trying to dive into that zip folder, we can, you should be able to see everything. Okay. So I'm going to stop remote control, and I'll stop your share, and I'll go back. All right. Does anybody else have any
Thank
issues?
you.
Okay. Everybody's good. All right. So what we have is a little polyline here, and it's just from a start point to a bend point to a bend point to an end point. It's 2D, and we're going to use that as our starting point for an alignment. Now, this would be if you wanted to draw your alignment in the drawing. You could have it already drawn, in which case you would just select the center line. Now, it would probably have curves already drawn for you. Or you could even, on our center line menu, choose, design, center line. I'll just call this one junk for right now. And it wants to know what layer to put it on. If you want tangents on a separate layer. And those are, when I mean tangents, I don't mean the tangent part of the alignment, but the extension past the curve that goes up and meets at the PI. And whether you're going to draw the alignments, give it a starting station if you know what that is. We're going to just use it for 0, use roadway curves, and then design mode, prompting versus existing. So if we say, or design versus existing rather, we'll say okay. And now it says pick a point or a point number. Well, I'm gonna go up there and grab that endpoint because that's my starting point. And now it wants to know, I can put these in all kinds of ways. I can either pick a point or a point number, or if I pick a point, it's going to be expecting that to be, maybe the PT of a curve or what have you. Or if you say PI, that's one of my options down there. If I say PI, it says, okay, so pick a point for that PI. So I'm going to go over and grab that endpoint. Okay, and now it wants to know what type of a curve, a spiral or a circular curve. We're just going to use simple circular curves. I can give it a design speed because it's using design tables when I use this design function. And then you could give it a radius as the default, let's say a 200-foot radius. And it wants to know the next PI. Well, I'll come down here and grab that. And now that sets in where that curve would be, okay? And it wants to know, do you want to do a reverse or a compound curve? At that point, I'm going to say no. And then you can continue. So that's using the design process, okay? But it's really kind of simpler to do this if we have these starting points. I'll go ahead and undo that business. If we have these starting points, we're going to just turn this into an alignment because it's already drawn. Now, you may have a PDF file, that has that drawn in it, or you may just have the reports that show you what they are. So anyway, you can put these in, and as a simple alignment, we're going to have a starting point, and all of the bend points are PIs, and then we're going to put curves where all those PIs go. So let's look on the center line menu. Instead of the design, we already have this polyline drawn, even though it doesn't have curves in it yet. And I could say polyline to centerline file. If you choose that, it wants to know a centerline file to write. And let's just call this, well, you see you've already got Main Street and Side Street established there. Let's call this one Plymouth Drive. Now, it says it should have been drawn in the direction of increasing stations. It's just telling you that it's going to increase in the direction that the polyline was created. In this case, it was started here, it ends here. Select the polyline that represents the center line. I'm going to select that, and it shows you the direction it was made. And it gives you the option at this point, if you need to, you could reverse it by typing R. But right now, by default, it wants to know a beginning station. I'm going to leave that at 0 + 0. I'm just going to hit enter. And it runs through some points here that tells you those line intersection, line intersection, line intersection, and then finally enter to continue. So I've now done that, and I have a centerline file. So if I go into edit, my centerline editor, it's going to ask me for the file. There it is. I see a preview of it. I open it up. And there it is. And I can select different things, double click them and change, lengths and values, etc. Okay, but I've got everything basically in now. And again, you can adjust, you can pick a different starting point, you can type coordinates, etc., etc. I'm going to change my curve type to roadway. I had mine set on railroad because I used that last. So I'm looking at this line. And so instead of starting, so one of the options here is to hold the other PI points if you change the starting points. If you don't do that, it will pick this whole thing up. If I choose over here as a starting point, it would pick that whole thing up and bring the whole alignment over. If you turn it on, it will hold these steady. Okay, so we're going to just take what we've got started and we're going to sit up here on this first one and we're going to fit a curve. So down there at the bottom, fit a curve. And you could do it for all the PIs, or we could just do the one. And if we put in let's say a 250-foot radius, it calculates all these other parameters for us, gives us the coordinates. Now we could look it up with horizontal speed tables. We could find, what size we need and the super elevation rates. And we could, choose whatever comes out of those. You see at a 55 mile per hour design speed with these super elevation rates, let's change that from 4% to a 6%. Come down to 55. Well, you see the minimum radius is quite large to be able to drive at that speed, even with a 6% bank. So maybe that's a 35% speed. And so we still have to have a minimum radius of 340 feet. Well, that's good highway design, but we're going to close that. Just come back here and just use 250 feet. So this is not a safe design. And you're going to see on the vertical, it's going to be too steep in places as well. But we're going to take what we've got just to learn the tools here a little bit. So I'm going to say, okay. So now it's put in a 250-foot curve between those two tangents. I go down here to my next line. I'm going to fit a curve. And I'm going to put that radius in at 135 feet. We'll say, okay. Now that has a curve down there to end it out. I'm done. I'm going to hit the save button and exit and watch what happens. It redraws it on the screen for me automatically. And it does that because under settings, Carlson configure, general settings, I have right here, link line work with center lines. So what that means is that if I edit that center line file with that editor, or even if I do something like double click that polyline, it knows it's a center line and it loads up the editor for me automatically. If I go to curve and double click that last curve, I'm going to say hold the PIs and make sure I'm tangent to the previous element. And let's change that radius from 135 to say 150. We'll say, okay, save and exit. So now it's updated that for me automatically. Likewise, if you simply grip edit this line, I'm going to take it from the endpoint back to the midpoint. So I've changed the endpoint of that center line, and you can see it's now that shorter segment. So it links both ways. If I just do a grip edit out here, it will update that centerline file automatically. Okay, so if I now put this back, double click that, you see it's now larger. Okay. Now, a couple of things, we've got our centerline design based on that, but even if we didn't, if all we had was that centerline file, so I erased everything there, I can go to centerline and say, draw the centerline file. I'll put it on this layer called C line. I could draw the PI lines if I needed. I could label the center line. And I'm going to load up CSW CL stations as a file. And that is, I'll show you what that sets up a lot of the text sizes and such like that. So I'll say, okay. Let's see. It didn't load the. Oh, said I missed it. There we go. Now, say okay. There's my center line. And there now is the drawn center line with the labeling, symbols, the tangent lines. And if you wanted, you could select those and put them on a separate layer if you wanted. We'll leave them there. Let's go to the center line layer. It's going to be down here. We'll change it to be a different color. And we'll use a center 2 as a line style. Double check our LT scale, MSLT scale. There we go. Now we'll select these 2 tangent lines and we'll make them specifically white and continuous. Now I've got my little station ticks. You see there's my 1 to 2, and then there's a 1 plus 50. Now, you can, if you do that again, you could draw it again or simply station the polyline, the center line. And this is that settings file that we loaded up before. We loaded the settings, CSW, CL stations that was delivered with it. I could have another one that I may have set for some other project. And you see the tick sizes are now different and they span across. And I no longer label things out here. And that's based on all of these settings where you set up the label, what layer it goes on, what size to make it, what markers to use, what markers to use for the PCPT, etc. Okay, so it takes a little bit of fiddling around with some of that stuff to sometimes get that done correctly. All right, and notice when I did that, I had a setting down here that told it to erase the previous and redraw. If I can find where it is, where they moved it. Oh, right here above it. Erase previous station labels. If I didn't have that on there, it would have left those old ones. So anyway, that's just something for you to use for a reference mistake. And then again, if we were to move this, change the alignment, it would recreate all that stuff with us as long as we have settings, Carlson configure general settings link labels with line work that would recreate those if that happens to move. All right, so now we have a horizontal alignment and we need to make a profile to go with that. And we can do a couple of things. We can design a road profile. We go into our profile editor and we would call this one a new one, and we would call that Plymouth Drive. And then it wants to know a centerline file to use. Well, there's our Plymouth Drive. And what is going to be used as the existing ground? There it is. And it puts us in our profile editor. We can double click that or resize it if we need. And we can design a profile based on that existing ground. Now remember, we're in the vertical mode of fit. If I look at it, there's the actual terrain. All right, so this just helps us to be able to see our design in a little more detail. All right, so before we get into that, I'll say no, don't save it. We also then have on our roads menu, a place where we can design a template. And we'll call this one the template file to create. And we'll call this one 2-lane with curb. And it brings up this template editor where we could start putting in grades. So now I've set that up. I could put in a standard curb and whoops. CLB. So that's our curbs, and then you could do your cuts and fills. And a 3-to-1 slope. So that would be a basic surface only template. Okay, and so we would do our edits there. We would add subgrades, etc. I'm going to exit that and not save it. And the reason I'm doing all this not saving stuff, because I'm going to show you where even though you've had to go to centerline, design your centerline, go to profile, design your profile, go to road, design your template, you can do all that in one spot on the roads menu. Actually, 2 different places, either process road design or road network, both of which will allow you to do that stuff from one location. Now, when you process the road design, it's going to bring this up, which is a little control box that you set all the needed files, and then you can generate the road after it's done. Road network, which is sort of the flagship road design and so let's call this, instead of Plymouth Road, we'll call it Pilgrim Estates. This brings up a different control over here, but we then have, if we add, now we got to set an existing surface first. It sort of looks at that. And we're going to select this center line. A design profile would be a new one. And then let's just cancel that for the moment. So, oh, sorry. And we'll do this Plymouth profile and then say, okay, it's missing a template. And we'll call it basic 2-lane with shoulders. And then say, okay. Now, it's going to go through and it's going to recognize that we've now added Plymouth Drive. But notice these other topics here, intersections and cul-de-sacs. Road network allows us, beyond just that process road design, to have an entire network of roads that might intersect and cross. You can do an entire subdivision. In fact, we did a job with a large design company called Dewberry that had like 160 some different road center lines in a large subdivision. And it took everything all together, kept the intersections at grade. So if you adjusted the profile of one road, it would pick up the roads that cross it and keeps everything all together in one network of roads. So this is sort of the top guy. And if you look at this, where you set up your files, then you can edit them with the button. That is similar to, I'm not going to save that, this part under process road design, which is meant for just single roads at a time. So that was where we set our files, we set our edits, and we hit OK and say go. All right, so either one of those will work. Process road design is for a single road. Road network is for multiple roads. So each of those places where we set the files is where we will do the same things like creating, polyline to center line, design profile, design template. All of that can be done within there. So let's do it from that in that regard. So if I say roads, road network, it's going to come up and ask me new or existing. I'll say new. I'm going to call this one, I'll just keep it the same one, Pilgrim Estates. I now have an empty road network package. Set. Let me save as instead of O Pilgrim. Type it correctly here, Pilgrim Estates. There we go. So now these buttons are somewhat self-explanatory by their pictures. We add roads. Over here, we can choose edit, or you can just double click the road once it's added. You can subtract a road, reset settings, and we're going to look at some of these settings here in a minute. Create a new road network file, help system. This is the process button. This is what, once we're ready, we hit that button and it goes through and it does all the processing. And then this generates our reports. This can draw different components of it if they're not already drawn. Save as, or load a different one that we may have out there. And then of course, exit. So the first thing we want to do now is set up some settings. So if I click my settings button, notice my tabs across the top. I've got processing options. Existing surface is set to none. So if I click that and choose my existing surface, it's created it. Now, if I have a rock surface where if I go down, that's going to interfere with some of my excavations, I could set that separately, but I'll leave it as none. And our station interval means how often do I cut a cross section along my roadway? And that's going to be every 25 feet, except if I encounter a crossing roadway where I have an intersection, once I'm in that intersection zone, I'm going to tighten that up to go every 5 feet or whatever number you set. You can create special sections if you have stations that you want to make sure that you get. Like if the centerline stations would also go to the PCs and PTs. Profile stations would go to where the vertical curves start and stop. Any super elevations and template transition stations. That's if I change from, say, a 2-lane with curbs to a 3-lane with curbs. At that transition, make sure I cut a section at there as well. So I'm going to choose those. And now the existing section maximum offset. This is how far out left and right it's going to look to find the existing ground once I get my road built. And that can be, if you set it to be, say, 50 feet and you haven't hit the ground yet at 50 feet out, it's going to still go ahead and finish processing, but it won't know the numbers. It won't calculate the volumes of materials within there. And the reports will go along and calculate where it will, but when you run out of distance, it's going to say it exceeds the station boundaries and it gives you that warning. You could then just go right back to this and up this and reprocess, and it would take care of it. Process on update design files means if you change this stuff after you've already processed and you've got surfaces built and everything ready to roll, you can have it automatically update. So if you change the horizontal alignment or the profile, it recognizes that it changes and it goes back and it reprocesses for you. Or you could turn it off so that you always have to hit the process button. Or you can say, prompt me, tell me if I've changed something and need to reprocess, and you can decide to do it or not. Because you might want to change your profile and then you still know you want to go and edit your template and you don't need it to process that intermediate condition quite yet. All right. Slope perpendicular to, and these are the cross slopes of the roadway. Now, if you guys have not ever used yours, what is yours set to? Center line or slope direction?
Ours was set to center line.
Okay.
Center line.
So and that's fine for that. And that means when you're calculating these slopes, like the cross slopes of the pavement, it's going to be 2% away from the center line. And if that center line is on a slope, you see, that's still going to be 2% away from the center line. If you say from the slope direction, that's a little more conservative, but it changes the cross slope of the pavement a little bit when it's in there. So it's a subtle difference, but just understand when you're making that change as to what it does. Now, an example of, I'm gonna go ahead and say, okay, here a minute, I'm gonna go ahead and draw you something real quick. To show you what that means. So if you got a situation like this, and so you're down here on a part of the road, and then you go up a ramp, a graded, ramp up here to the top, whether this is a road or even a graded pad, it doesn't matter. When you look at your contours, let's change these. All right, so I'm going to just try to illustrate this like this. All right, so maybe the contours that are in our grading would come across like this. Now, from here, this will have a slope down this way and then a slope out that way and a slope down. So if we say perpendicular to the slope direction, just in general, let me draw now another one. Here's what that means. When you set in some of our grading tools, you'll see that same question come up. Do you want to be perpendicular to the edge or perpendicular to the slope direction? And what that means is when you're telling it to be 3-to-1 or 2-to-1 or whatever slope that you want to design that slope at, it's going to calculate it like this. If you say perpendicular to the edge or the polyline or the center line, it's going to compute the slope this way. So it would set that at 2-to-1 like here. So if you said perpendicular to the slope direction, it would go down, whatever, like if this is kicking back this way, it would calculate down this line because that's going to be perpendicular to the direction of that slope. And now if you notice this, the line between these two contour lines is longer this way than it is this way. Okay, so if we say perpendicular to the slope direction and make it 2-to-1, it's going to put this little short distance in here, which would then move, it would then take this distance instead of that distance, and it would move it up like this so that this now becomes our 2-to-1, and then this becomes less than 2 to or steeper than 2-to-1 because it goes from that contour to that contour in a shorter distance than it did this way. And this is the way most of the plan reviewers are going to look at those drawings. They're going to lay a scale down and calculate that slope and maybe discharge your design, not approve it because they say it's too steep. So that's the difference in those two conditions, but we'll leave it set. Go back to my settings and we'll leave it set to center line as my perpendicular. So that's going to give us that. Now, tied to existing is going to be whether or not when it goes out here and gets to the final edge, it goes out and seeks that original ground. So if you turn that off, it won't seek this, but it still needs that surface. So in case you want to, it knows what to target. And then processing intersections. That's again, if we have an intersecting road. So let's just set these up like this. And let's take a look at some defaults over here. We'll leave these as 25, 20, 15, 25. Hold main crown. Allow a single. Let's use PVI so grades in and out. And we'll go transition across the intersection. Cul-de-sac right to left, standard radius value there. I'm not going to use design parameters to check. I'm going to now look at my display options, and that just basically says when I select it over here, how do I want to see it in here? You can either thicken it, dash it, or none. I'll leave it thickened, and then highlight the current intersection of cul-de-sac with a target or with a pointer, which is an arrow instead of a circle. We'll leave the target on. Report options, you set your precision as to however you want it. Use a report formatter so you can define the actual parts that get reported. Let's leave that off though, just take the default. We'll report the cut and fill into areas. You can report the differences if you wish. You can set in shrink and swell factors. You can report also subgrade and topsoil areas. And you can report the accumulated cut and fill as it goes station to station to station. And now on the output options, and this is the one that gets rather lengthy. right up here where it says triangulate and contour, just like we've been doing before with our triangulation stuff. If we turn that on and we choose the setup button, that's going to be just like we saw before, with the exception of it doesn't have that filter out here. And it doesn't have some of these controls down here because it's going to choose them for us. So we don't need to draw any of these things up here. We can always create them later from our file. But the big thing we need to do is to write that triangulation file. So if I select, and I'm going to give it a name, this will be a new one. I'm going to call it roadway surface, roadway surf. So that will be the file that the processing kicks out for the road itself. Okay, so now we also have the contouring and labeling. So if I say draw the contours, okay, I want to do that. And I forget what these layers are on, but I'm going to prefix this with an RD dash, C for civil, topo. Oh, it's got an RD at the end of it. So let's take the RD off. And yours may just say CONTMAJ or MINR, whatever. But give it some name. In this case, I've got what did I call it? C. C road. These are all. So C topo major. And then I put dash RD. So that's going to be on its own special layer. Whoops, except. Say C dash topo. Put it on minor dash RD. That's the main, that's the individual contours. And we would set a contour interval. We'll look at 5 footers right now. I forget what those are. We'll go back and change it if we need to. And now for the index contours, we want to draw them separately. We'll set those on C topo dash where did I? Oh, C topo dash major, and we'll put an RD on that. And again, if you have all these settings already done from another project, just make sure you have saved them and then you can load them back. All right, so we'll look at that 5 and 25. We got the layer assigned. We may need to change the line styles and weights and such. We can look at that later. We are going to contour by interval. That's what reads this instead of a specific elevation. We can do all kinds of things to reduce vertices. We're going to leave those turned off and have no smoothing. We're going to let it generate the contours just like the surface says to do. And then on labels, I'm just going to make sure that's unchecked. I don't need to see the labels on there right now. So that should be good for now. We'll say okay. So now we have set up this part of it, the triangulate and contour. We could say merge the road with existing, which does the same thing like we did before lunch, where we triangulation file utilities, load the existing, load the roadway, merge them, but you can do this all in one step. And we'll call that set, and we'll call it road dash exist dash merged. And when it draws the surface, You can choose, once you've said merge, you can choose to draw the road only or the merged surface. I'm going to just do the road only because I still have these contours out here and you will see where they tie. And then you've got all of these output options down here, in which case, let's look at this output coordinates. And I'm going to choose the setup button. And up here at the top, it says file none. I'm going to choose select. I'll go to new. And I'm going to call that my roadway design base CRD. And we'll go ahead and let it overwrite. And which template ID, I don't have any in here because I haven't defined a template yet. So we're going to just leave it either blank or put something in there and just leave it like that for now. Output both sides, and we're going to draw the points and we're putting them on a layer called road point. And what we're going to generate, we're going to include the station and the offset in the description. And the stations we want to output are going to be our profile low stations. And the reason we might want to do that, and you'll see it, is because when it processes and goes through our profiles and generates all our design, if there's a sag in that low part of the profile, it's going to drop a point over on the edge of the pavement, which will be the perfect place to put an inlet for our storm drainage. Okay. So that's really all we'll generate from there. We'll say, okay. And all of these different things, pads and lots, if you're designing subdivisions and want to set building pads and such, but you're going to usually be getting all of that stuff. You can set the layers for the different options, and we'll just keep them, but we'll just keep the defaults as they are and change the colors if we need to later. And our output file settings, if we click that button, we're going to turn all these on and leave these as suffixes to add to the layer names of those elements. I'll leave that up there till you guys get them copied down. Just give me a thumbs up when you got that. Okay. Jason Downs, there we go. All right, we got it. All right. So now we have some things that are being output. We have some processing controls. We have some defaults, different curve settings, like when it comes to an intersection, what radius to apply to the edge of pavement, that sort of stuff. We'll say, okay, and let's go over here and save our road network file. Now there's nothing in it in terms of roads yet. So first thing we do is add a road. Now you could screen pick a polyline. So if that were already drawn, we could just pick the screen. We already have the centerline file, so we can choose that. Plymouth Drive. If you have not done that, it will, when you pick that centerline file, it will go right into that same command we did before, centerline profile or centerline over the polyline to centerline file, and it steps you through the same process. We've already done it. It got the file. Now it wants a design profile. We'll choose new. We'll say Plymouth Drive. We'll open that, and it's going to overwrite it, but because we didn't make any changes. So now here we have it, and you can give it a different name up here if you wanted. That doesn't change the name of the file. It just changes it for reports and such like that. You can limit the range of stations if you just want to look at a little bit of it, or go the full one. You can put in gaps, like if you don't want to do cut and fill in certain gaps, like you're going over a little bridge, you can turn the cut and fill off from station to station. Tell it not to process a template from, again, like if you're going across a bridge, you can turn on and off the curbing. in those gaps, that sort of stuff. We'll leave those off. Now, notice up here at the top, it has some required input files, a centerline, design profile, and a design template or series. Okay. Then down here are some optional input files where you can control some of this stuff with with some variations like template transitions, template point profile and centerline, so that they can depart the normal template definition and follow something else. We'll show an example of that in a minute as we work on it. And then some optional output files. These are the cross-section files. You've got the existing cross-section, the design or final section, and rock section. Then you've got an existing profile. So it takes this design profile name and puts an EX on it. And then if we wanted to show our super elevation diagram, now we're not interested in generating drawings. We're just going to use these files. Now, we still have one design or one input file that we need to choose, and that's our design template. So if we choose that, now we can use an existing one. You should have that basic 2-lane with shoulders in your folder. So if we do that and choose open, now we have everything that we need. Our edit buttons go into, you've seen that one before, our profile. Now, right now, we haven't done anything, so it's going to start on the ground where it starts, go to the end where it ends, and there's no vertical curves in there. So we're going to need to add some vertical curves in here. And then you've also got the template editor like we saw before. Now, in this case, I've got a 12-foot lane with a negative 2.08% cross slope, 12-foot distance, and it's going to go out and set an ID point called EP. Now, why do I have 2.08% instead of 2%, which is really more typical? But that is because that is the old carpentry standard for roof drainage. That's a 1/4 inch per foot. So it's just a little nuance there. And then over here is a shoulder segment at a 4% slope. And because I've said right side same as left, right here with this checkbox, anything I put over on the left side automatically gets mirrored. And I tell it I want my left side to show the fill condition and my right side to show the cut condition. I could change them to be both, either way around. And that all that is showing me in this editor. And if I were to plot this as, say, draw, and I just take the defaults and see if it's going to give me what I want. I'll pick here, and we'll look at that in a minute. So that's the basic road surface. No ditches, no curbs, no subgrades, nothing yet. We'll save, we'll exit. Now we still, if we went ahead and said okay and we processed, remember this profile still has no curves in it. So let's put some curves in it. I'm going to open this up a little bigger. And you can see as I track along, it's showing me where I happen to be, and I can see the red line as my existing ground. So let's look down here at the bottom at our setup button, and we see where the stuff gets set. The reference center line, that's the center line horizontally that we use to determine it. It's already set. Again, you could point it to a different one, but we'll leave it to that. And you could show the reference surface or not. If you uncheck that, this surface won't show up. So we'll leave it there. And we also write down below that where we say output the reference surface profile, it's going to put a -EX on the end of that same name, Plymouth Drive -ex.pro. So it's going to go at the end of the file name, then it's going to say ex, which indicates that's the profile of the ground. And it's going to sample this existing ground everywhere it cuts it and put in all the PIs of all those different points where it changes. Okay. Then you've got a couple of things here that control the editor, like what happens if you drag a PVI, you want to hold the vertical curve length, or you want to hold a K value or hold a sight distance. So as you move a curve up and down, you can control, what gets generated there, because it ties all this stuff together with proper road design stuff. Now, right here shows centerline special stations. If I turn that on, see these red mark or these green triangles rather? Look over here in my plan view. That's the PC of the curve, PT of the curve, the PC of that curve, the PT of that curve. Now you might want it there to make sure that you're not putting a vertical curve in part of that horizontal curve. That's considered bad design. But again, you're not going to normally be worried about design. You're going to be putting in the values that you get from somebody else's design, somebody else's set of plans. So you would just basically read the profile sheets and you would go down here and type in the station values for the PVIs, type in the curve lengths, and if they had sight distance or slopes values and all that kind of stuff, that's what you would put in there. All right, so for now, we're going to just generate a couple of things here. And we're going to use these buttons at the top. We're going to see there's an add a point of vertical intersection, and then you can edit that point of vertical intersection. And so if we add one, it's going to say add a PVI. So I'm going to come up here and I'm going to click one right up here. And it reads that station and elevation where I clicked, the incoming and outgoing slopes. Right now it's got a vertical curve of 0. I'm going to make that a vertical curve of say 400 feet. And that gives me a certain sight distance, and I can tell it to snap to the nearest 5-foot station and the nearest 0.5%. So it went to 825 at a 10.5% slope. I'll say okay. And now I've got a vertical curve that crests right where that marker is there. Right between those two peaks. You see the peak here and the peak here. That's where that vertical curve peaked. Now I'm going to add another one. And I'm going to click this one down here a bit further and give that a distance of, say, 100 feet. And I see there's my 100. This one was, I wanted at 400. Let's make it a little smaller and say 350 exactly. And then I'm going to add one more down here. Oops, so that one's too long at that vertical curve. Let's make it say 75 feet. All right, so I'm coming back in, I'm landing that at a -4% slope to come into the end of my road. Now, everything, if you see, even the sag curves don't have a low spot that's lower than the other parts of the road. Like right in here, I don't have a sag point, so I would not get those points to be output. If I edit the PVI and I choose that edit button, I'm going to come over here and I don't have to snap, I just click near it. I'm going to pull this down. Let's see, I'm going to click and hold the mouse and I'm going to drag it down so that now it does go negative. And you see that low spot would be right there. I'm going to up the length of that to say 125. And let's edit that. I'll click and drag it. So that now would be the low point, and you will see our points get generated there for us to put our inlets. Now I'll bring that up a little higher. Let me. Whoops, I'm too far. There we go. Let's. And it like so, and so now we'll have a low spot over here. We'll come in. Now we've got quite a bit of cut right there. A little bit of fill, a little bit of fill. So this is not a really ideal roadway. Okay, but we'll use this to start with. So let's say save and exit. Now we have a center line, a profile, and a template. Let's go ahead and process that, and we'll say okay. And it tells me that it's changed. You want to run process? Yes, I do. The template changed? Yes, process. Okay, that was my prompting. Now, so what you're going to see here is it's going to calculate how that road gets built. Now let's go through and change those layers so we can see them. We had C dash topo major road will make red, minor road will make green. So there's now the contours, and this is our daylight line. That's where our cut and fill meets the existing ground, and you can see the contours tie right into the existing contours. Okay, so there that part is. I can look at my reports button and choose my output processing, and you can see here's my total cut, my total fill. Got quite a bit of cut. And here's now for Plymouth Drive what files were used, the station range, total cut and fill, and then there's my 0, 0 plus 25, all the way through, and then you can see the special stations like 2 plus 75 was one, but 2 plus 75.24 was one of those PCs or PTs, or it might have been where the vertical curve started. But anyway, it does all of that. It tells us how much cut and fill at those particular stations, what the interval is, cut and fill in square feet, that's the area of it in the cross section, and then how much volume. And notice as it does these, that's at each individual station, and then this is the accumulated totals. And as it runs to the end, see it all brings up that total cut, total fill. All right, so that's a very basic, very simple road design. I'm going to go back here now and hit save, and I'm going to exit. And anytime in the future, if I've lost all that stuff, I can load that stuff up and rerun it so that it would generate all that. Now let's see what we have. If we just select and view it in our 3D viewer, you can see how it created that surface. Same thing if we view the surface, there's our roadway surface, and you can see the various components. Get a little bit of shadow casting here. And you can see that it actually generates the triangles. There's the shoulder area, the pavement area, and then the cut and fill that went out to create a roadway. If we view the merged surface, you can see what it did. It merged the road into our existing ground. There's where the ties down into the existing ground. And you can see, you know, it punched a hole down in here. And if I zoom in there, I can see those 2 points right there. That, and you see that red contour line. That's the low part of that roadway. That would be where I would put my my drainage inlets. Okay, now I'm going to go ahead and select those 2 and just delete them, just to take them out of the drawing, because we're not going to use them anymore for that, because we're going to do some changes here now. So the nice thing about RoadNet as a processing system, let me see, I've got a straight pointer down here at 0. So the nice thing about that is that everything stays tied together that was being used. So if I just go back to roads, road network, it loads up the last one I used, or I could choose, you know, open one. And so there it is. There's that road. If I double click that road name or hit the edit button, it brings up my control. Now I can go back and make changes. I can edit that profile. Instead of having that so low, let's open this up a little. And I'll even show my sections. I'll see the cross sections. And when I show sections, as I move along, it's going to show me where those sections are. Let me this is what's going on. Okay. It's no longer tracking. Let me turn this off. Well, if that caused a problem. Looks like it did. But normally what I was going to show you of this is when you show your sections up here, you can get an idea of your total cut and fill because it's accounting for this amount of material out here on the sides. And instead of just checking this, you can make adjustments here up and down until you get a balanced condition. Now, again, you're not going to be doing that so much when you're building somebody else's design. You're going to just take what they got. All right, now I'm going to have to kill this, I think. If yours did the same thing, I have to right click my taskbar, run my task manager. See if I can end that. All right, so that's there. If I can't exit though. Let's try that one. Oh, no, it's going to make me have to kill it. All right, let me see if I can save. Yep. And let me exit. Start over. Okay, now we've got this. The marker that was left over. All right, so now the nice thing about having that road net though, as you can see, then go right back to it, process it. Let's edit the profile now. And I won't load up the sections at this point, and I'm going to edit this PVI to take it up a little bit more reasonably. I'll save this and exit, and I'll say, okay, now it's going to tell me that it's changed. I'll say, yes, reprocess. Now keep your eye on what happens. It goes through, reprocesses everything through all kinds of triangles. Let me set my settings here. Wow, I didn't keep that. All right, so let's put these on. C-dash topo. Minor road. There's going to be a 5-foot interval. Draw the index. C-dash topo. Major road. No labels. Write the file roadway surface, so that's good. Now, you may have noticed, I'm gonna go ahead and say okay. Say yes, say okay. I'm gonna save those settings. Must have missed a save. Maybe reprocess that so the contour intervals are gonna be correct. There we go. Now, you may have noticed when we viewed that surface, roadway existing merged. You see these different colors? That gets set in our settings, in our output options, our triangulate and contour setup. Right here where it says set colors and layers. So if you set the colors, now it has read the template. It found that EP, and you can set it to a particular color. It read the shoulder. Well, let's make our shoulders sort of a dark green. Then our other, we'll make it, oh, say this more bland looking. And then outside, I'm not really sure what that is. It's part that goes outside that final bit of cut and fill. You can see the difference there. And then we'll say exit. And say okay. Yep, okay to overwrite. We'll say okay. And now let's reprocess that. So now when we view that surface, let's even look at the roadway surface. Now you see those different colors that I changed them to. And if I look at the merged surface, they're going to also be, oh, it looks like that was the same color as the existing. Maybe we'll set that to a different color. That was 43. Let's make that one 41. Make that one 43. To sort of match. Exit. Okay. Yep. Okay. Save it. Process it. And then we'll view that merged surface. Yeah, it's a little bit better. So you can get an idea of where that works. Now that is a single surface, even though it's all colored with those different components. Okay. And like right in here, the reason that's yellow instead of green is for that part of that, the downslope of the cut and fill happened to match the same as the cross slope of the shoulder. So it picked that up. So, you know, you could go in and individually edit this and change the colors, but for the most part, you'll probably not see that very often. All right, so let's go a little bit deeper now. And let's make a real template that could be something we'd be interested in. So we're going to double click our Plymouth Drive. And instead of this basic 2-lane with shoulders, let's change it to a different file. We'll say new and we'll call it 2-lane with curbs and sidewalk. Okay. And let's edit that. Now it's nothing in here, so we're going to learn to use this editor real quick. And you're going to be building those cross-sectional templates based on what you see in the design plans like this. You're going to have certain thicknesses, cross slopes, distances out, that sort of thing. So we're starting at the center line. Say right side same as left so that it mirrors across. And we've got grades, and those are the tops. Curbs is that special structure. Medians allow you to put medians in the middle between grades. Subgrades are going to build those materials underneath. And then you've got super elevations, cuts and fills, and you can set right-of-way limits, etc. So let's look at the grade first, and we're going to set the grade based on a percent or a ratio or a vertical difference. We'll say percent, and it's going to be a -2%. That's our typical road. And we'll set the horizontal distance to 12 feet. And we're going to call that EP or edge of pavement. And we'll say okay. So that now has our 2 road grades. Let's then, because we have put this in, we're now sitting out here at the end of this. So let's add a curb. And you've got these different types pre-built for you. And let's see, I'm not sure the difference here is going to give you batter heights difference. Let's just take this standard one here. Curb 1 type, we'll use inches for our dimensions. If it's going to be integral with the pavement or separate from the pavement, we'll keep it separate. With no rounding, you could choose rounding and it will round off these sharp edges. It's a little wonky looking, but there's a lot more detail than we're going to have time to go through. That if you want to look in the curve or in the help system under civil, under roads design template, this shows you all kinds of nuances. There's those smooth and rounded curb types. So this shows you all these different conditions. Again, we just don't have time to go through all of that part of it, but it's a really good resource, so make sure you use it. Okay, so we'll take curb type 1 in inches straight. The base will be flat, or you could have it match the crown of the pavement that comes into it, or set it at a particular one. We'll just keep it flat. And we'll set the dimensions here. Across the top, we're going to have a 5-foot top. So it's going to have a 5-inch top. So it's going to have a 1-inch taper. It's going to be a 6-inch curb, but laid back an inch. The width, which is the gutter width, will be 12 inches. It's going to have a 1-inch drop down here at the flow line. And it's going to be 6 inches thick under the ground. And then the height, because it's going to be flat, we want it to be a 6-inch high curb. That's going to be a 12-inch height too. And the overall base is going to be 18 inches because that is the 12 inches plus 1 inch plus 5 inch. That's our total 18 inches. And now in our materials, let's just call that concrete for concrete. And we'll call it CRB as the ID point. And we'll say, okay. So now I've added a curb to both sides. All right, so let's add another grade. And let's make this one at a 2%. Well, no, let's make it a 4%. And let's just make it for 2 feet, and we'll call this one just a little grass strip there. We'll call it strip. So now it's gone out here 2 feet away and now that point out here is called strip. Okay. Now, again, if you can select these different things and, move them up and down, change their order, that sort of stuff. Now I've got this part got mirrored. But what I want to do is let's put a sidewalk in on the left edge. So I'm going to uncheck now this right side, same as left. And I'm going to copy this over. And let's see, I've got a button down here to copy left to right. So I took everything on the left and copied it over. I'll go out here to my strip, and now I've got this unchecked. So everything I put out here now is going to be by itself. So I'm going to put a sidewalk out here. So I'm going to put a grade. It won't have any cross slope on it. It'll just be flat. And it's going to be 6 feet wide. And that's going to be called SW. So that's my sidewalk. And I'm going to add one more grade at a minus 4% for 2. And I'm going to call that STR-2 for my strip 2. That's the little strip beside on the other side of the sidewalk. So I've got a strip coming up. The side, whoops. We've got that strip coming up. Then it goes to sidewalk. Then it goes to that strip over here. The other side, oops, I've got to change that curve. Notice I copied it over so it didn't mirror it. So I'm going to double click that curb and I'm going to change its direction. I need to call that curb R for right. Oh, what did I do here? There it is. Okay, so there's my curve R. EP, my EP curb. All right, so that sets our tops. Now, let's set our subgrades in. So I'm going to choose subgrade. And I'm going to go out from my center line. I'm going to match the crown or match the surface. And I'm going to intersect by simply continue slope. And the horizontal distance, horizontal offset, I could put in as 12 because that was my lane width. But here's a trick. You can use EP because we named that. So it's going to go out to wherever EP is. Now, the reason I'm doing that is because I may have something that changes this template and makes this lane get wider in portions. So that will push the subgrade out with it, and it will always follow that EP point. Now, the vertical offset, I'm going to come down here to the right and change it to inches. So how much below the surface do I want this first course? And I'm going to put a 2-inch, so I'm going to just type 2. Oh, I'm sorry, I put this in the wrong place. That was the offset. That means it's going to start at 0. But here I want EP to be the distance it goes to. And I'm going to go 2 inches down. And I'm going to call this one let's call it ASPH-WC, asphalt wearing course. And I'm not going to worry about the super elevations at this point. I'm going to say okay. All right, now that went in that direction because I'm no longer right side same as left. So I need to come over here. I need to actually do that same business from this edge. So our subgrade will be inches, 2 inches, EP distance out, ASPH-WC for my wearing course. And so now you see I've got them on both sides. All right, so let's add another subgrade. And this one is going to go also to EP. And it will just continue the slope. All right, sorry, not that, but EP distance out in inches. Now, this offset is, let's say I've got say a 4-inch binder course of asphalt. So, well, let's not say 4. Let's keep it at 2 inches. I'll go back and change the other one. But now the 2 inches. Hang on, let me come back to this. Let's change that from 2 inch to just 1 inch. Same thing here. Oops, same thing here. All right, so there's my 1 inch. And now if I add another subgrade, I'm going to go out again to EP, continue the slope in inches. Now it's going to be 2 inches thick, but it is 3 inches from the top of the surface. So I have to keep adding those down to it. So if I just said 2, then it would go down 1 inch for the top and then another 1 inch. So I'm going to go down 3 inches. So I'm setting the bottoms of these subgrades. And that's going to be asphalt-BC for binder course or base course. And so now you see that. Now let's put our aggregate. And if we put that aggregate down, oops, I need to add that to the other side. I need to copy this left to right. There we got that. So now back here on the left, I'm going to add another subgrade. And this time I'm going to keep my intersecting surface straight up. You'll see the effects of these. No offset. My vertical is going to be, now remember I've got 1 plus 2. I'm now 3 inches down. I've got 3 inches to the bottom of the curb. So if I have an 8-inch thick stone, I need to add those 3. So I'm going to make it 11 inches. And the distance out, if I just said EP, and I called that number 57 stone. See what it did? It went out to EP and went straight up. So if I changed that and said it needs to go beyond EP an additional, let's say 12 inches. Well, except it went feet, sorry, EP plus 1. See, it goes 12 inches, and if I wanted to get beyond the curb or exactly to it, I'd put in 18 inches. Well, let's make it, say, 24 inches, which is 2 feet, sorry, that part's in feet. And it wraps the stone all the way up to the top. Now, you might ask yourself, well, what if I went to EP, why can't I go to CRB as a point on the curb to make that happen instead of EP plus 2? If I just went to CRB, it doesn't happen because that CRB is a structure and it's not actually a grade. So that's why I need to go EP plus 2 feet, and 57 stone. That was straight up. If I did a tie slope of 100%, it would look like that. That's a 1-to-1. If I did a wraparound, my wrap height, I'm down 8 inches, so I'm going to come up to 12 inches as a wrap height. So that's going to go around it and up and tie back, but below the top of that surface. So now I need to now it's not drawing that correctly. Let's keep it straight up. And then I want to take this one and copy it to the right hand side. All right, so that now has that part done. And now over on the left, I need to put something from the strip to the back edge of the sidewalk. So strip is my offset, sidewalk is going to be my width. So I'm going to put a subgrade under that. I'll just do straight up. My offset, I'm going to go over to strip, and I'm going to make, say 4 inches, and the distance will be, what do I call that, point SW, and that's going to be, let's just call it sand. And I'll put one more. Again, I'm going to go to strip. And so that was 4 inches of sand. Let's make it 6 inches out to sidewalk of number 2B stone. All right, so I've got, and let's make our sand 2 inches and our stone. That'll put 4 inches under the 2 inches. So 2 inches of sand, 4 inches of stone because I'm 6 inches down, okay? So that now has our structure made with the exception of this business over here. Something about copying this stuff right to left. Let me asphalt wearing course. Three. Base course. Then we'll add 11. So we tie slope, or I'm sorry, wrap around 12 inches. 11 inches, it's going to go out EP +2. And that's going to be our number 57 stone. Wow, it's something. EP +2, 11. Well, it's just something with yeah, it's just something with the way it's drawing this. Because if it's defined exactly the same, it will process the same. I'm going to save that. I'm going to draw it up here beside this one and see what it looks like. Exit. Say okay. I know I'm not going to process it yet. Let's go up here and look at what we've got. There was that original one we drew. Now here's this one. And even though it draws, I don't know why it's goofing that up. It has something to do with the fact that it's not mirrored. Oh, I see right there. The curve's still backwards. So back to my editor. This curve should be like this. There we go. Now if I draw, save, exit, say okay. No, I won't process it. Let's go up there and look at it and see. There we go. That's much better. So it's got these labeled and you can move those things around. You can see it's identifying there's 1, 2, and 3. So it identifies those materials. 4 and 5 over here. And you could bring those slope labels up and move them around. They're just text. There's your name, strip, sidewalk, strip 2. All right, so there's that part. We have one more thing that we need to add in our template edits. We didn't account for any cut and fill. So if I choose cut, we'll just take a 3-to-1 cut, or let's make it a 2.5 to 1. So it's not quite so bad. And our fill will make 3-to-1. It might be a little less consolidated. So 3-to-1 on the fill side, 2.5-to-1 on the cut side. What do we have? Well, that doesn't make sense now. I've got this. Oh, I don't want that. Yeah, that's what I wanted. So that's going to come down to the back of the curb there, but it's going to have a sidewalk over on this side. Okay. So I'll draw that now. Save, exit, say okay, no processing at this point. Come up here and look at what we've got. Now we've got our cut and fill slopes. 3-to-1 fill, 2.5-to-1 cut. And you can bench those, you can put them in at multiple slopes based on depths, all kinds of different nuances that you could do. Okay, but again, you're going to take the drawing that they give you and you're going to build in these components, doing just like we did here. All right, so that's now our template. We'll save this network file and we're going to process it. And so now we have a different set of surfaces and contours, and you can see, that contour comes right down, comes across the top of the curb, goes down the face of the curb, up to the shoulder, across the crown. Works exactly like we'd expect it to. And if we look at our reports now, we've got quite a bit of additional things here. We're still it looks like we're bringing a lot more fill than cut because we raised that vertical curve up. But now we also get these accumulated subgrades and the curb materials, and then station to station as it creates those. Okay. Now, that again is for that single road. If I look at that surface, there I can see the road with the crown. Crown of the road. See the curbs. The little grass strip. We need to set the color for that grass strip. So output options in our settings. If they're set up, we set the colors. Now we've got an edge of pavement. Curbs will make cyan. Out to strip, and then sidewalk will also make cyan to be our concrete, and then strip 2 will make same as this, which was 41. Other and outside, that should work. Exit that, yes. Okay. Save, and then process. And so now you can see our concrete with their curbs. There you go. See that the curb on the left-hand side? I'm having to change the light to get the shadows to make that curb stand up a little better. I'll put it in the middle. There we go. I can see them now. Curbs on both sides, the strip, and then where the roadway then goes out and ties back to the existing ground. Now, here's the fun part. Let's draw in. Go ahead and save that. Let's draw, and again, you've got a complete, grading plan. Everything's set. You've got those reports. You've got those cross-sectional shapes. So let's go and just simply draw a 2D polyline. And I'm going to come down here and choose the layer as C line. The color will be by layer. The line type, I'll make that center too. Say okay. Now I'm going to go from here to here, and then let's say down to here. Now, because I have a road there, I'm going to come back to my road network, choose add. I'm going to add a road. I'm going to screen pick a polyline, which is right here. And it says no centerline files associated with it. Well, I'm going to assign a centerline file to that. And I'm going to call this, let's say Salem Road. Wants to know a profile. I haven't built it yet, but that's what I'll use. Salem profile. And now my design series, my design template, I'm going to switch that one now and choose that basic 2-lane with shoulders. And it could have subgrades and all that. We'll just use that one though, so we can mark it. And you can see how this works. I'm going to edit the profile. And now you see what it's doing is it starts at the ground, comes down here to this end and ends at the ground, but it comes up and crosses our main roadway up here, puts in a couple of little transition vertical curves. And right in here, we've got, see, right at that station, we've got a incoming slope of 2.127 and 2.219 or 19 going out. And the reason it's not exactly 2% like that cross slope was is because I'm not exactly at 90 degrees going across there. It could have been if we had chosen. All right, so that's how RoadNet forces that to come up and meet that existing ground. Now, I'll say exit to that. I need to actually change the center line. We got to put a curve in down here. I want to fit the curve, just make it a 200 footer. Save and exit. And now let's edit that profile. And I'm going to add a vertical curve here. We'll just make it 100 feet. I'm going to add another one down here. I'll make it 150. Okay, so it's going to be almost entirely in fill everywhere unless I make an edit here. Pull it down a little bit. Notice their upcoming slope is like 38.3%. Well, that's way too high. Now I could change this and pull this. Well, I don't want to do that. but I could bring down that PVI up here to match this crown, but then I'd have to go back and adjust that other road that I did. So let me edit this. I'll bring that down a little bit like so. We'll get a low point. Say save. Now that's where it crosses. We'll say save and exit. And we'll say, okay. And no, I'm not going to process that one yet, because I'm going to go back to this road, Plymouth Drive. Well, let me go back to change the name of this. And you don't have to do that, but let's go back to Plymouth Drive. And let's edit that profile a little bit. Right there's where that road crosses. So I want to pull Plymouth Drive down a little bit more. Than what it was. Say, okay, no, don't process. Go back to Salem Road and double check it. And you see how it pulled it down. So that's going to be almost entirely in cut. So I'm going to raise Plymouth Drive up just a little bit more. More like that. Don't process it yet. I'm going to double check. Yeah, still. I'll bring that up a little. So it's not quite so steep. There we go. That gives us a little bit more. So it comes up at 18%, it comes down at 15%. That's really not the best road design. You can see the conditions for this are not all that good. So now it wants to know if it wants to reprocess. I'll say, go ahead. And you can see now what's happened. I've got that sidewalk, the curbs along our main street, and they have to end because this road doesn't have them. Of course, they wouldn't be in the intersection anyway, wouldn't go across the intersection. But if I had sidewalks over here or curbs over here, you would see those curbs continue on as it went through that intersection. Now it identifies the intersection, and I can double click that, and I can change things like my curb radius. Instead of 25 feet, let's make that 35 for the front left, front right, and we'll say 35. Just upping these settings. We're going to hold the main crown. Our main road is Plymouth Drive, and that should be good to go. We'll save that and process it again and take a look at what it's going to turn into. All right, now let's take a look at that resulting surface, our merged surface, and just some leftover triangles that we didn't really color correctly. And you can see where the sidewalks come down, the curb and gutter, and then it still made the surface as curb and gutter, but it changed the colors of the triangles. And those are just for display reasons. That's not to be a huge issue. Let's go back now and take a look at this intersection. And we are using the edge of pavement to transition around the intersections, surface method. We want radial from the curb instead of holding the main curb. Then when we process, you'll see the intersection. Blends these two as it comes across. Okay, so we keep this crown of the side road and it even comes into the middle. And that was because it went from the curb out, just split the difference. If we turn that back to hold the main crown, it comes up here and crosses that, but you get little wrinkles in the side street when you do that. We'll turn that back on with their intersection. Hold the main crown. And that. All right, we'll take a peek at that difference now. So now you can see where the main crown gets held. And it sort of warps the transition across here. Okay. Now, with that geometry set up and established, this being our center line for our side road, if I just pick this up and I'm going to grip edit this road, come across it here. Yes, and yes. So now I'm coming across at a different angle. I've got finish there. And you see all of that stuff gets taken care of for us automatically as part of that transition. Now, I've got a couple of little, see those high spots in this road right in here? I can control that a little bit better with my intersection processing by setting down the vertical curve defaults in the intersections. Right, this profile transitions, if I make that, say 30 feet, 30 feet. And now let me double check this profile, see if I haven't corrected. Yeah, because I moved it, I need to bring this guy up. Maybe bring it down a little bit on here. We'll get that a little bigger distance, save and exit that. Say, okay, let it reprocess. And once that does, we'll save our network file and view our surface. Now you can see it's smooth. Well, it's not all that apparent, but it's smoothed out some of that in there anyway. Okay, so bottom line is that network will keep track of all that stuff for you and just reprocess, and it recomputes all of our reporting. So it gives us the Plymouth drive, runs through its processing, and then it picks up with our totals. Down here. And then we pick up on Salem Road. And then all of this stuff can be saved. It can be output to a spreadsheet. It can be, generated as reports and then used to calculate your materials. And you go through it. And then when we exit that, come back in, we could then station our center line. And this time we use Salem Road. So now we've got the roadway stationed on both of those. Contour lines are drawn, and it also draws these 3D polylines that you can see in 3D. You could freeze those if you don't need to see them. In fact, I'm going to go to turn off my existing contours. And now you can see how it runs those out there, and then it stops them halfway through that transition curve. But it takes the EP and goes on around and matches this EP and comes around that 35-foot curve radius that we defined in the intersection part. Okay. And the same thing with those, you can then also add on a cul-de-sac. Just put it on Salem Road. And just take the defaults there. Process that. Save that, exit, take a peek at our surface. And you can see it brought that in. Remember, it didn't have curbs around this one. It just had that shoulder. Okay, so, and if we had those other components, it would match those and just push them right around with it. Okay. Any questions on that kind of stuff?
Oh, we're good.
Okay. Now, let's do a little bit of some grading designs that you would, again, from over here. There's a bit more of one in here where we put a building, a parking lot in. I think those are pre-drawn for us. Looks like we got one, but it's gonna be right where that road goes. So I'm gonna go to my road network. I'm gonna take Salem Road and take it out. Double check that. That's a good enough profile. Yeah, go ahead and process that. And I'll erase these layers. Of course, that also took that one out. I'll put Plymouth Road back. Take out the .3D line work. And again, just make that white continuous. Save that, exit, not exit. Yep, exit, we've already processed it. All right, so now while we're in with this file, we're going to insert. So I'm going to go to the draw menu and choose insert. And I'm going to choose from file. I'm going to look in my folder. And I want to get building footprint. And I'm not going to specify any insertions or scales or rotation. And I'm going to check that I want to explode it when it comes in. So it comes in not as a block, but just as a polyline. So that's going to be our building. And we're going to do this one more time. Insert from file. And we're going to bring in the parking lot. And you see it just comes out to here. I'm going to actually extend that to the center line. Now you get the idea. This could be a part of that road network as we come into our parking lot. Well, I'll leave that to your own devices. You could then also put a curve in here. So that would be our entrance coming up into our parking lot. But to match what we're going to do here, if you follow through these procedures step by step, you're going to see this, how you're going to handle grading those two different elements. Okay. So when you grade for a building, you want to create this as what's called a design pad. And so that's going to be on our surface menu, and we have this design pad template. So now, much like the road edges goes out and seeks the existing surface, we can do that, or we could seek a particular elevation. No, it's not letting me do that. Let's see. There we go. So we could seek a surface file, or we could have it go out and try to find things drawn, or we could go to a particular elevation. So for instance, if this were a pond and we wanted to go inside, we could have it grade down until it hits a certain elevation. We're going to go to a surface file. We're going to go to the outside. And we are going to choose round exterior corners, draw the side slope polylines and color them and space them every 10 feet and a 10-degree corner delta. We'll leave these values set like they are and not trim the existing contours. And we're not going to write this final or merge anything together. We're going to put this on, what is that in C? Well, let's just call it pad. Just call it pad. Okay, so we pick a pad polyline, we pick this one. And it asks for the target surface. Well, that's going to be, we might as well use the merge surface. So in case it were to go out and hit those side slopes, it would already have that. Now it shouldn't hit that. It shouldn't be the same results. And let's use 3-to-1 side slopes for cut and fill. And it reads this, reads the ground elevation and finds the range of existing elevation. Goes from 105 to 122.5. And it wants to know the pad elevation. So if we set that pad at a particular elevation, and if we wanted to sort of match our cut and fill, we would go to something in the middle of, instead of, let's say, 105 to 22. So it's about, 8 feet. So let's call it 112.5. All right. Now adjust and redesign. We're going to say no. And we're going to look at what we've done. Right now, all that we've done is create some 3D line work. Okay. So the red lines are in cut, the blue lines are in fill. So if I were to build that pad at that elevation, that would be the resulting lines that define that grading. So we haven't built a surface out of it yet. All we've done is generate the geometry. Well, that's not a bad thing to have if we're doing that. But if we're doing this parking lot also, then we've got a problem because we're running into our building cuts. And we also have an issue of, when we build this building, do we really want that cut and fill to come around here, or do we want a sort of a standoff around the building and grade that so that this is sort of flat, it's all the same elevation, as if the building were rectangular. Okay, so I'm going to come up and choose edit, erase by layer. And I'm going to hit this clear button to take out those other layers I had before. Select layer from the screen. I'm just going to pick one of those drawn lines and say okay, so they cleared that off. And so now let's do this as far as a building pad. So I'm going to go to my 3D data menu and I'm going to say draw the building envelope polyline. That'll put it on whatever layer. And we're going to offset. Let's just offset 5 feet. You can do difference for the sides, elevations, etc., trimming. We'll just leave it there. We'll say 5. And select the building that we want. There it is. So there's what it's done. We'll say no for any additional. So we've taken the building And we've drawn a perimeter polyline around it. Now it's just down at 0 elevation. So if we grade this instead of this, we won't get all that tight stuff in here. It'll all be relatively flat. In fact, we might even say want to bring this in. And if I bring that in to match the back of the building, it conceivably could match, you know, it could be filled up a bit on the building a little bit. So the building's sort of tucked into the pad in the back. So now, if we go back to surface, design pad template, and say, okay, we're going to choose this now instead of the building. We'll say, we'll keep the fill slope at 3:1, cut slope at 2:1, a little stabler ground. And there's the elevations from the low to the high. Let's put it up a little higher than low. Let's make it say 115. And so now that's what it would look like. We'll say no. So if that was at 115, we could set this building in to be 115 or 115 and a half, so that it, you know, can drain away from the building pad that we prepared, anything like that. But that's going to be our pad for our building. And we can again see that in our 3D viewer. So you see where it has to cut out and fill in. Okay, so now, if we did the same thing with surface, design pad template, I'm going to call this one pad dash PK for parking. And I'll say here, target here. And let's say we went 3:1 fill, 2:1 cut. And the elevation there we had at 115 before. We'll call this one at 113.5. And now we've got this. We'll say no, don't adjust those. So now what do we have? We've got a situation now where things don't match up. So you've got the side slopes of one coming down to hitting the side slopes of the other. So there's a solution for that. I'm going to go back and now edit or erase by layer. Now the solution for that is design pad template. If we use multiple pad polylines. So now we set up which one gets ordered or gets created first. I'm going to take these all the way out and now add we're going to choose pad. We'll take the building pad. No, let's do the parking lot pad first. And then let's add the parking pad. Now notice you're doing the layer names as to how to process these. And you can give, if it's in cut, 2:1. If it's in fill, 3:1. Say okay. And Gonna fix this. First of all, this has to be on. That's proposed parking. So proposed building, all right. So our design pad template, multiple pads. Instead of that, the layers that I chose were the layers that the line work goes on. I want the layers that the outline is on. So that's on C proposed. Parking. And this one is on C proposed building pad. Now that should work for us. Give it to target surface. We'll check these, and now for this one, it wants to know the elevation. So we're going to make that one at 113.5. So it grades that one first, and now it wants this one. We're going to set that elevation at 115. And so you see what it did was create the intersection of where that slope hit. So it temporarily used the grading for this pad as a target surface. And it wants to know a final surface. I'm going to say none at this point, just so we can look at it and see how now we don't have that overlap. But we do have an interesting situation here. Look at that. We've got, in fact, if we turn down the existing contours, you see that? There's no real need to have that crown. It's because this was in cut to hit the original ground. This is in cut to hit this ground. But I could, because all that is just a wedge shape, I could even get rid of these things in here and let this edge meet that edge straight along. Okay, so that's sort of some manual work that I'm going to be doing here. So I'm going to go to my polyline toolbar and I'm going to remove some polyline segments here to get that trimmed back to there. I'll remove that one. And now I'm going to take this. Move it up to there. And let's remove that segment. That segment. Now I can remove this. Oops. This. So I can remove all of those. And then tie this back in. I don't even need that anymore, really. So if I draw a 3D polyline, I'm going to draw it on that layer. Set my color to be by layer. I'll say okay. And I'm going to go from this point here out to say, well, let's put it down here at this point. And anyways, those I will remove this polygon segment and then get rid of this. And I'm just going to draw in enough of these 3D lines to help tie in my grading design was what I missed. So I'm going to see that. And that should be okay. Let's take a look at what we do have. Oh, see, I've got a bad edit. Because when I snapped, it didn't read the elevation. So I'm going to go to my settings, set my view, exit, and then I'm going to, while I'm in 3D mode, instead of snapping to that, I'm going to snap to that. All right, so that should have done it for me. Go back to plan view. One more time to check. And that now would create that. It probably needs some transitions right in there. So let's draw a 3D polyline again. We'll go from this elevation to that elevation, excuse me, and then again from that elevation down to that elevation. Let's make sure that is not at 0. It's not at red, the elevation. And then I'll put one more just down the middle here. From here to here. Read those elevations. They're good. And we'll just verify it. So that now should give us a little better surface than having those two come up and meet with that triangular shaped fill region in between. So I'm going to then isolate that geometry. Again, verify that I have what I need. Looks good. Now that could be a pretty rough transition in there, but we'll give it a shot. So I'm going to now draw a shrink wrap around there, because before, when I had those individually, these were closed polylines, but I broke this apart in the middle. So I'm going to need to now draw a new shrink wrap. This would be around bounded line work. And all I really need to find are these. Outside edges, there it is, closed. I'll verify by looking, yes, it's closed. And I'll triangulate and contour, and I'm going to call that one pad. So I'll write the file, I'll call it pad. Oops. Not pad one, let's call this pad. Done. And we'll draw. So 5 and 25. And then we'll put this dash pad. Pick inclusion, no exclusions. Set our data. And there now is, I've got a intersection, but with no vertical difference, so that's okay. And there now is where those contours would go. And you see how they would tie in. Let's change those contour colors so they're a little clearer. Something pad. I will make the major. Say that color. The minor. And that so pink color. And then if we freeze, the side slopes. In fact, let's also see. Let's also freeze the perimeter. There's now your grading plan for that pad. And you can also go into your triangulate and contour. I'm sorry, triangulation file utilities. Will load up our road existing merged. We'll go next, and let's merge into that. Our pad combined. So that comes in over here. We'll save this as total merged. Exit that, view it just for yucks. And so now with, we could clean up a little bit of some of that in there. To clean out some of that in there, maybe make a smoother transition across that. Same thing in here, but we took out that crease. If we had not taken out the crease, it would have come, to those rising slopes because they were in cut. Okay, now, with that being an example, let's go back to this. Get rid of these contours. And this is on proposed parking, proposed building pad. Let's go back one more time and take a look at something else we can do with this. Design pad template. We'll keep that same process multiple and say, okay. We'll go back to that road existing merged. We will select. Oh, shoot. Let me escape that, and I need to get rid of also. Oops, that. There we go. Now we're back to where we started. So now in our design pad template, keep all that the same. We'll choose our road existing merged. We'll choose this. So our fill slope and cut slopes will set the same elevations. Oops. Okay, so they're there. Okay, so I forgot to get that one and that one. So now that elevation is 115. I keep hitting the help button. Sorry about that. 115. All right. One more time here. Because I picked the wrong pad. So that one and that one. So that elevation is 113.5. That elevation is 115. No new surface at this point. So now we've got a surface surrounded by that, surface surrounded by that. Now that surface doesn't close, it just comes up there to meet that, so you could use that to build a surface out of all of this stuff. But what we have is a pad now, just like we had on the center line of the road where we double click it and it brings up the road editor. If we double click that pad, it's going to bring up the pad editor. So I double click the building pad, and if I wanted to change its elevation, let's drop it down a foot. So I'll change that to 114 and process. So you see it change slightly there. Now this one, I lost my extra pad. Yeah, there we go. So now let's make that one 112. Process that one. All right, so this is not letting me do my multiples. But let's say if we wanted that, and if I look at my report, I've got 4,500 yards of cut, but only 163 yards of fill. So if I want to balance that pad, I'll choose balance. I'll say okay. And now that's how it's going to balance, and it's going to set the pad at 117.536. Okay, so if I now, because that's up at 117.5, let's make this 118. Process that, see what that looks like in terms of cut and fill. 800 versus 5,000. So I could balance that one. and it would drop that down to 114. So now my parking pad is actually quite a bit above my building. But again, because I've generated this 3D edge work, I could go into those 3D, into the 3D geometry and make those edits. So I could have my parking lot, instead of coming out here and targeting it all the way down into my building, I could have it stop right here along the building and walk its way around and adjust it accordingly. You could even do things like this one. Let's say maybe the best approach is to move that pad. So from there, I'm going to go from here, I'm going to move it out a little ways and process that. So now I no longer hit the grading from the parking lot. Of course, I'd have to move the building with it as well. If I balance that, looks like it stayed in a balanced condition. If I report it, there it is. So if I move from that midpoint, that would put it right. Okay. And then that is at 114.2. My parking lot is at 117, so it's a little bit higher up the hill. I can either take that or I can choose to make that 115 or something like. And change the grading if I needed, different things I can do with these edits, okay? Now that one's 2,000 versus 600, not really enough to trifle with, but there they are. And then if I isolate the pads, let's triangulate and contour one more time, and we're going to still call that one pad combined. So I select my inclusion perimeter, excuse me, they're both there. No exclusions. And here's the data. And it is contoured as well. I'm now going to freeze the pad geometry, restore my layers. I've got this contour, which is actually the same elevation as the pad. That would be exactly the same. That's back to 0. So that pad was at what, 115. Bring that up a little bit, 116. Process that, exit. Now let's select the contours. Isolate. Grade the surface. Select our inclusions. No exclusions. There it is. Done. We'll restore, we'll freeze these sidelines. And there's now the grading plan for that parking lot and that building. And if we load now the road existing merged, go next, and now merge in our pad combined, show up over here, and then save as our total merged, exit, and view it for confirmation. Now you've got a road, a building pad with a parking lot, and of course, you would probably want to take out this intervening material, or, you know, build a set of stairs or a walkway or something to make sure that that gets accommodated. Okay, and there's all kinds of additional nuances in there that you get in the civil stuff as well. Things like you can use a sloped pad, use a sloped pad design, and you give it a slope percent. So once you select the pad that you want to do, you tell it which direction you want it to slope. Like you can go from one corner down to the other corner. And it basically creates that 3D polyline with the slopes that it takes to go at that downward grade. Or upward, however you wanted to do it. Okay. So the basic idea of what we're doing here is we're using drawn 3D geometry. And if I go back to put everything back on here, I need to get rid of this one. And let's freeze. So we're taking all of this drawn geometry. Now the RoadNet part did it for us when it generated those and left us with those. But we could certainly use those to build an independent surface because of using that command, triangulate contour. All we need are these edges and three-dimensional geometry to be able to define what that surface looks like. Okay. Back on. So that's sort of the whirlwind tour. You'll see that same type of thing. You see that raised hump that we talked about doing the edit. It'll step you through those. Same thing with the road design, intersections, a little bit of drawing cleanup is another tool. And this is starting to get into each of those commands that we've been using. And again, the red ones are the ones that I think have some particular good value. So as you go through those, you might take note of those. You know, some of them are okay, some of them aren't necessary. But there are things in here, including in the survey parts. Although this being the civil manual, you're not going to see the survey commands in there other than the points. Okay, so take a take your time, go through these exercises a couple of times, and get familiar with those tools. Read the sections at a little more leisure. We don't really have time to sit down and read and discuss and have a book club situation out of the deal. But things should be pretty clear for you, I hope, as you go forward. I know right now, as a result of what we've done in class, I'll go ahead and I'll put this back on just as a conversational thing. So what we've been doing in class is sort of like drinking out of a fire hose. I understand that. It's a lot of stuff coming at you all at once, but go back with that manual, go through those things over again, and let me also reiterate this particular manual that is in, let's see. We'll get to it here. All right, it's in this other PDF file that you got in your download stuff called the Carlson Takeoff Manual. And again, some of these are going to be a little dated, but the process remains the same. Now you're going to get through all of these commands at length. And then you're going to come down to these tutorials and you're going to go through this CAD file takeoff. And that shows you the SiteNet way of doing things by layer management. Oh, here it is. And let's view that as a double page. There we go. So it's going to start you off with, again, the sample drawing is included in your getting started folder. It's also in your Carlson settings folder. Shows you how to go through drawing cleanup, setting the targets. There's where we define the things that are on certain layers become existing and design. And then we process, build existing, build design, and then run reports. And that's really all that it's doing for you, with the one exception of when we had these closed features. Let's say this building pad, if we have a layer that represents a building pad, you're going to be able to then define a material, and you give it a subgrade name and a depth. And you can even assign cost for different units, you know, whether you can buy your stone, like you may just have a rectangle drawn for a parking lot that's going to be a stone parking lot. Well, you know, you can calculate that from the CAD file as just an area in square feet, but it's going to be 8 inches deep. Well, but maybe you buy your stone by the ton. So you're going to put in here a cost, and you pull this down by the, choose it to by the ton, and then you type in how many pounds per cubic foot does that material weigh. And then when you run those reports, it's going to also append the cost values as well as the volume values. But this goes through all of those different things, 2D to 3D. How do you elevate things? How do you elevate contours that might not be at the right elevation? How do you elevate line work like this that shows top of curb, whatever FS is supposed to mean. But based on labels in the drawing, see, these are all tops and bottoms of the curb, and it will step right around that 3D polyline and set those elevations based on those text labels. So that gives you a good step through of that in the excuse me, in the takeoff method or SiteNet. See, there it is. We're going to convert that as a curb line. You're going to get not just the tops, then you can do an offset and then set the bottoms, and that will create that curb structure for you. So this is going to step you through that one at a time. Go ahead and build this, shows the subgrade adjustments, cut and fill color maps, volume comps, and then it goes through another little road design, uses a different surface file, but basically the same thing that we just did. There's your profile. And here's our template editor. Again, it's showing you all of that, including looking at the viewer, and that used process road design. They didn't talk about RoadNet because RoadNet didn't exist when this thing was written. Again, it's got some age to it. So it processed that single road. And then it talks about some geotech if you've got drill holes and geotechnical data, how to process that stuff. And it gives you all of that information here. So it's a nice little approach. This one uses a trenching, so you can see how to do pipes and pipe networks and to account for the material that's cut out of those pipes. And let's see. See, you put in a ditch, basically like a road template, but it's a ditch template. It's basically the very same thing. It can even colorize and report your trench depth zones. Here's 0 to 15 feet are red, 15 to 20 are yellow, 20 to 25 are green. Anything over 25 would be, whatever colors you assign. Okay, so there's some good value in some of these other materials. Just make sure you take your time and go through some of that. Now, the rest of the rest of this tutorial is on digitizing. So if you have drawings that are just printed, how to set up a digitizer. Well, this is, again, it's got enough age on it. It's back in the day when we used to have a digitizing tablet. We don't really do that anymore. We take the PDF and bring it into the drawing. We just do heads up digitizing. So maybe not a lot of good information with that particular stuff. And that shows you digitizing, the design, excuse me, the design versus existing. And again, that's your basic premise is you're creating existing, you're creating design, here's your materials and subgrades. Again, this is all from the takeoff perspective. Okay, topsoil stripping, cut and fill color maps, all of that kind of stuff. And then you get into the index and stuff like that. So that's a good little in-depth look at that. That's another resource. One last little resource to point out that you may not be aware of is on your help system. If you go to the Carlson manual, if you look down at the bottom, there's this section called tutorials. There's your CAD basics, and it will actually step you through, some exercises, how to use layers, how to draw with, for surveyors, entering a deed, making a plat, field to finish processing. And this one is really quite extensive, as you can see. But it really kind of steps you through that whole process of field to finish to creating a map, ServNet, which is your least squares adjustment, contouring, DTM, and design. That's our surface modeling. That's basically what we've been doing. Some of these things are not necessarily the way I would approach them, but they get the job done. There's, they're building a dam across a valley fill here, or creating a valley fill dam. And then hydrology and watershed, you don't necessarily need. Road design with volumes. Again, you can see that's basically that same thing you saw in that other tutorial, but a little more details. Road rehab, 5 methods of volume computation, stockpiles by layers, by grid surface, by triangulation, and by cross sections. 12, a dozen different tools on designing surfaces, how to build those graded areas. Bench pond, design pad templates, that's what we just finished up. Okay, so all of those different tools are sort of stepped through independently. Take off site net, CAD file from start to finish. That's basically that same thing, but with newer tools in it that we talked about before, like elevating those lines. And there's your resulting surface model, cut fill maps, etc. There's your drill holes, trench network and quantities. So again, look at them there, look at them in another book. PDF cross-section imports. How do you import things that are just drawn cross sections? How do you enter your geotech data from your reports? Cut sheets on how to generate your stakeout reports. Pressure pipe networks don't really need that. So there's some good tutorials there. And there's also, finally, under that, you've got on the Carlson website, these online training movies. If you go to that, it's going to kick you into Carlson's YouTube channel. And they're here under different categories. We have different channels. It's we've got uploads or all videos, different playlists. The playlist will be by category. Some of them are in different languages. So, you know, there's just a wealth of things to go through there. And the nice things about these are let's see if I can. Well, there's 400 rooms. The nice things about this is that some of them are, you know, so here's an entire playlist. If I view that survey, there's an overview of Carlson survey, how to create a quick profile, how to export surfaces in Civil 3D. So they're, you know, 2 minutes, 3 minutes, 6 minutes. They're very short videos on how to do the work. Carlson layout, there's in 2021, different categories, different tech tips. Connecting devices, registration, that's for your Serve CE, it looks like. Well, it looks mostly survey. Okay, so explore that, use it as a resource. And the nice thing about that is it's not, you know, 2 straight days of throwing everything at you rapid fire. It's going to step you through just very specific things like, how do you design a pad? Done. Or how do you design and grade a road? Done. How do you generate those? And so watch those and see maybe a different approach. It might get something better. But the key thing that I will tell you that you should always, always do is when you're doing this work and you're modifying this stuff and manipulating it around, always, always look at this stuff in 3D to make sure it's doing what you want it to do. Okay, same thing with, say, our roads. Look at resulting surfaces that you generate to make sure you don't have something wacky going on. A client out in Montana once, years ago, that he was trying to do something like 30,000 acres of mining area on a strip mine. And he was bringing these in like quad sheet next to quad sheet next to quad sheet, and then building a surface from those contours on those quad sheets. Well, that was fine for some areas, but then he got down into these bottom portions and none of those contours had been elevated. They were all down to 0. Well, his surfaces were going from up there down to 0, and it was dragging his machine to its knees. It couldn't process all that kind of stuff. It couldn't calculate things fast enough. He couldn't figure out why, because he never once looked at this in 3D. The first thing I did when I looked at it was I just spun his drawing up. And again, you can do it either right here in the drawing, or you can do it in the 3D viewer. And it was once I did that, and I noticed he had all this stuff down here, and all this other stuff was up here. And so that told me right away how it was to go about to fix that. Now, one last little trick that we talked about. Let me isolate these two layers. To go. So if I were having to build a surface from this, and let's say I'm going to turn all of this stuff to 0 elevation, and say I had to elevate those. Now you remember when I used construction that it would turn everything red until I changed the elevation of the polyline. And I told you that you could do that with construction or takeoff, but you couldn't do it with SiteNet, even though we had this set of colors. Well, here's sort of a cheater way to do it with civil only, is you get the things that you're trying to elevate. And maybe they have a particular color. Isolate those, select everything, and change their color from what's usually by layer, make them some particular color, call it red. And then if you choose this command of assign contour elevations multiple in series, look what you can do with this. You can tell it to change the polyline properties. And I'm going to make this 5 and 25. And you can even change the layers that they're on. But you can change their color back to being by layer. Now, I need to find out what is the layer. That's C topo minor and C topo major. So if I group change these contours, type S for settings, I'm going to change the polyline properties. So much feet at a time, 25 feet, and the contour is going to be C dash CONT dash minor C dash right topo, not CONT topo. But the color is going, I'm going to change the color back to by layer, or you could make it a certain width or whatever. So I'll say, okay, so I'm going to start down here and I'm going to go up to here, say my beginning elevation, or whatever it is, and I'm going to go up. So once I've changed them, those have now magically changed color when I use that, and it also shows me which ones are elevated. So I can sort of mimic that, and I can do things like, if I knew this elevation was 1026, well, I could set this one to be 1026, but that won't change the color. I have to make sure if I do it by properties that I set it back. Okay. And then you can even change elevations to an absolute. I pick that and it says, well, I have to type an elevation, but I know that this is the same elevation as that. So one of my options on my command line is S to select. So if I select that, it reads that elevation, and now it wants me to show it which one I want to change, that one. Okay. And then you can continue that process as you need. Again, change that to by layer. But that's a way to sort of mimic that color by elevation stuff to help you figure out which ones you've changed or not. Okay. And then if you lose track, let's say you've changed these. That one's going to be 1036, 1031. 36. The reason it's not even is because I started at an odd number, 31, 36 instead of 30, 35. So now I've got these two. It looks like I haven't changed them. However, if I do spin that up, I say, oh, everything up there's changed. Well, I can just select everything up there and change its layer to by, change its color to by layer, and go back to plan view. And now I'm good to go. Okay. So just a couple of things. Now, with that, first of all, let me ask, are there any questions?
We're good.
Sort of run out of soap grease.
Good.
So what we want to then keep in mind is that you know what makes these surfaces. It's all of this data at elevation, and you just need to look at that and see, make sure that it's going to be giving you the right results. Our volume analysis is going to be always comparing one surface to another. We have all of those automated tools like the road design, the pad design, where it's going to calculate and balance and do all of those different tie-ins that we used to have to do manually. But get a lot of tools at your disposal, and then once you have those surfaces built, look at our surface import export and kick out those top down surfaces. Okay. Now, we're about 15 minutes over. You didn't get your afternoon break today, so I'm going to give you guys each an extra half hour of PDHs, which won't mean anything to anybody except Jason Fisher. But
Yeah, as many as you want.
this a little bit of a bonus on that. So I appreciate you sticking with it. Again, anything that anybody thinks of, either you can ask me now, I'll be glad to stay on a little bit later to finish up, or ask me next week, or send me an email. Anytime you get stuck on something, let me know and I'll be glad to help you out. Okay.
I had a quick question.
Stop that.
All the stuff we went over the last 2 days, is that gonna be, or are you gonna email us like the copy of this?
And I'll stop our recording.